then you need to do a bit of investment appraisal. You understand the concept of equations and inequalities. So we'll try as hard as possible to cover as many as possible for today's class. So in order not to waste much of our time, so let's take a look at the first. Understand the concepts of simple and compound interest, annuity, present value, and discount. So we take the first, sequence and series. A sequence is a list of numbers that follows a pattern or a rule. In other words, it's a set of terms arranged according to a rule or order. So sometimes it could be an endless succession of numbers placed in a certain order so that there is a first member, a second member, a third member, and so on. So we'll take a look at some examples. We have the first one, which is 1, 3, 5, 7, 9, 11, 13, 15. They are called odd numbers. So if you check it, the rule that applies in this case is there is an addition of two numbers. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, and so on. So the three dots is called ellipsis. An ellipsis simply means that it continues without end. Then the second example is 1, 1, 2, 3, 5. If you check this, the rule states that there are two numbers. The two numbers previously will be added to get the next number. So if you had 1 to 1, you get 2. If you had 1 to 1, you get 2. If you had 1 to 2, you get 3. If you had 2 to 3, you get 5. If you had 3 to 5, you get 8. If you had 5 to 8, you get 13, and that is how it continues. So the rule here states two previous numbers are to be added in order to get the next number. And that's what that is. Then the third example is 2, 4, 6, 8. 2, 4, 8, 16, 32. The next number will be 64. The next one is 128. The next one is 256. What this simply states is that you have a multiple, that is, you multiply the same number by 2, or you add the same number to itself to get the next one. So if you say, yeah, the rule is 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 8 is 16, 16 plus 16 is 32, 32 plus 32 is 64, 64 plus 64 is 120, 120 plus 120 is 256, 256 plus 256 is 512, and so on. It continues like that till infinity. It doesn't have end. So if you don't do it that way, then you can say 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128, and it continues. So that's the rule here. So all these are sequence, and I'm going to quickly tell you the reason when I'm done with the 5 examples why it is called a sequence, how you identify a sequence from a series. Then the next is 2, 5, 8, 11, and 14. Now, if you check the first 3, this first example has triple dot, the second has triple dot, the third has triple dot, but the fourth one doesn't have any dot. What simply means is that this one is saying that it has an end. The given numbers has an end, but here the given numbers have no end. The given numbers here, they have end, but the numbers given here, they do not have end. So in this case, the rule is 2 plus 3, 5, 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 3 is 14. And that's where it stops. So that simply means you have an end to this fourth example, but there is no end to the first 3 examples. So that means these ones here, they are infinite, while this one is finite. So the finite or the finite and the infinite numbers are part of sequence and as well series. So you can have numbers given with ending a particular number with a particular number ending in, and there are some numbers that will be given to you, they do not have end. So you have here 2 plus 3 is 5 plus 3, 8, 8 plus 3, 11, and 11 plus 3 is 14. So the rule here is addition of 3. Addition of 3. 2 plus 3. Then the next, which is the last example given here, is y, y square, y cube, y raised to the power of 4, and it continues without end. This simply states that there is a multiplication of y to every term. So the first one here is y. If you multiply it by y, that is y times y, that is y square. If you multiply y squared by y, you have y cube. If you multiply y cube by y, you have y to the power of 4. If you multiply y to the power of 4 by 5, by y, you have y to the power of 5. And it continues like that. So the rule here is multiplication of y to each term. Now, checking it for the first example, you have first term, 1 is first term, 3 is second term, 5 is third term, 7 is fourth term. So the fifth term will be 9, the sixth term will be 11. So here, the terms are infinite. They do not have end. Here, the visible numbers are 5, and that means you have first to fifth term. Then from the sixth term onward, they are infinite. Then you have first, second, third, fourth, fifth, and so on. But in example 4, there are just 5 terms. 5 terms are in example 4. Then example 5, you have more than 4 terms, so the terms are infinite in here. So let's move on. Now the formula for the nth term of a sequence is nth, that is nth, or you call it nth term. So this base n is the nth term. So the n is the base, then the t is the term. Then in this case also the n is the u is the term. So this is term n, or nth term, anyhow you want to call it. So that's why I started with nth. So the formula for nth term equals to a plus open bracket n minus 1 into d. A plus open bracket n minus 1 into d. So the nth term simply means which particular term are you looking for. Like in this first example now, if you are looking for third term, for this first example, you are looking for third term. The third term here is 5, which is obvious. But if you want to use this to calculate it, you need to know what a is, then the n. What number of term is that? Then the d simply means the difference. The d means the difference. So that's why I said nth term, any of these symbols, nth or t base n or u base n equals to a plus open bracket n minus 1 into d. Any of this you use to get this formula, that means the difference is involved. But anytime you are looking for this nth term, nth or tn or un, that's u base n, t base n, equals to a r raised to power n minus 1, then that means ratio is involved. So if you take mathematics further, then you know that this first one has to do with arithmetic progression, while the second one has to do with geometric progression. So this is arithmetic progression, this is geometric progression. But because we are now advancing to that level, so we take it at the base of sequence and series, so we understand what we're saying. So back to that. So example 1, I want to use this to work it out. Since A is first term, according to the terms, now let me quickly explain it. It's below it. The terms of a sequence are sometimes called elements. So that means the one here is the first element, second element, third element, the fourth element, which is also known as the first term, second term, third term, fourth term. So the terms of a sequence are sometimes called the elements of the sequence. So from the two formulae and the patch above, so this is the patch. You have the first formula and the second formula. So the two are formulae in plural. But in English or in generally, you call it formulas. The plural is formulas. But for maths or science, you call it formulae when it's more than one. So from the two formulae in the patch above, A is the first term, N is the number of 10, or should I say number of terms? That is nth term. Then D is the difference, and R is the ratio. Now, still working on the first example, A, we refer to it as the first term. So the first term in the first one is 1. So if you plug in 1 for A, plus open bracket n. I said let's look for the third term. So this is first, second, third. So for n now you write 3 there because that is the third term. And we said n is the number of 10. So A is 1 plus open bracket, n is 3. Then minus 1, close the bracket, then D. That is the difference. You say second term minus first term, that is 3 minus 1, that is 2. Third term minus second term, 5 minus 3 is also 2. The fourth term minus the third term, 7 minus 5 is also 2. So that means the difference is 2. So that simply means you have 1 plus, open bracket, 3 minus 1. Close the bracket, then 2 is the D. So if this is 1, 1 plus 3 minus 1 is 2. That's 1 plus 2. Still open and close the bracket, then the 2 is outside. So first thing you need to do is you do the 2 times 2, which gives you 4. Then 4 plus the 1 here, and that is 5, which is the third term. So we're going to look at a real example in the next slide. So illustration on sequence. So in this place, we have the worked examples. We have what you're going to try. Then we have assignments that you're going to take away. So worked example, find the next term in each of the sequence below. Make sure you're following so that you can be able to solve some of the given questions under try this. So the first one, find the next term in each of the sequence below. This is the first sequence, then this is the second sequence. Sorry, I forgot to say something. Back to the first slide. For you to identify sequence in a question, they must possess or have what is called comma. So you have 1, 3, 5, 7, like that. So comma has to be what is separating the first term from the second term to the third term to the fourth term. So in separating the terms, you need a comma to identify sequence. That's why it is a list of numbers that follows a pattern or a rule. So the pattern in which they follow themselves is separated by comma. Let me put it out. So it's separated by commas. So 1, 3, 5, So all the commas makes all these sequences to be sequence as they are referred to. So immediately you have all of these and you're going to make use of this formula. So the next term that you're going to be having is going to be separated by comma and all that. So to identify sequence, you need a comma. So when we get to series, I will tell you what you need to identify there for you to know that it's a series. So find the next term in each of the sequence below. So the first one and the second one. So the first sequence is 1, 3, 5, 7, which I explained earlier. The term, that is nth term, equals to A plus, open bracket, n minus 1 into D. That's the formula. So T5 equals to, so that is fifth term, because they said the next term. So this is the first, the second, the third, the fourth. The next term is the fifth. That is the fifth term. So that means you are looking for T5. And that is why you have T5 here. So for you to do this, you need to do first thing. You write out the parameters. A, that is the parameters from the formula. You have nth term equals to A plus, open bracket, n minus 1 into D. So the A is 1, which is the first term. Then the next one is the N. The N is 5. And what is that? The fifth term, which is this triple dot. That's the next term in the sequence. Then the D means the difference. What's the difference between the second and the first, the third and the second, the fourth and the... So the difference in each of the 10, in the middle of the 10s, is 2. That's 7 minus 5, 5 minus 3, 3 minus 1. So the difference is 2. So you are going to plug in all this into the formula. So A is 1, you plug it, instead of A, you put in 1. So instead of n, you put 5. So instead of n here, you put 5, then minus, then the 1. The d is the difference. That's 2. You plug it in. Then repeat. It repeats itself. 1 plus. Solve what is in the bracket according to board mass. 5 minus 1 is 4. Then the 2 is outside of the bracket. Then the T5 still continues because that's the term you're looking for. 1 plus. Solve what is in the bracket and what is attached to it before you do anything. You don't do 1 plus 4 before you multiply by 2 because the relationship is between this, not this. The addition has already separated this side from this side. So you are multiplying 4 times 2, that gives 8. So 1 plus 8 is 9. So the fifth term is 9. Now, alternatively, if you don't want to do it that way, you know that the term can be Tn equals a plus open bracket n minus 1 into d. And that is the fifth term equals to a plus 5 minus 1 into d. So 5 minus 1 is 4. So you can apply this formula, which is T5 equals to a plus 4d. So that means when you have T3, that will be a plus 2d. If you have seventh term, which is T7, you have a plus 6d. So you'll be subtracting 1 from the term and attach it to the difference. So that's what you're having here. So you're having fifth term equals a plus 4d. Then the d is known to be 2. So you plug it in. 2 times 4 is 8. The 1 is for a and it repeats itself. So 1 plus 8 is 9. So if you don't use this formula, then you can use this formula. So that is for the first question. So our fifth term is 9. So that's 1, 3, 5, 7, 9. And it's applicable like that to all terms. Then the second example under the term in each sequence is 2, 4, 6, 8. Sorry, 2, 4, 8, 16, 32. Not 2, 4, 6, 8. 2, 4, 6, 8 is even number. Why these are 1, 3, 5, 7, 9 is odd number. So any of those numbers that are not multiplying itself, that are just having difference, then you use this formula Tn equals to a plus open bracket n minus d into, so n minus 1 into d. But if it is the one that multiplies, like this is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, then you are going to make use of a different formula, which is the nth term equals to a raised to power n minus 1. I told you this is using arithmetic progression, and this is for geometric progression, because geometric progression has to do with ratio, that's dividing or multiplying. Then this one has to do with addition or subtraction. So that's what differentiates them. So that's why I picked just the question here and one other question from this. So you have 2, 4, 8, 16, 32, and so on. So the term we're looking for here is first, second, third, fourth, fifth, sixth. So we're looking for the sixth term. So we're going to make use of the formula Tn, that's T base n, the nth term, equals to AR raised to power n minus 1. So A is 2, which is the first term. Then n is 6 because it's the sixth term we're looking for. Then r, how do you get your r? You divide the second term by the first term. 4 divided by 2, that is 2. That gives us 2. 4 divided by 2 is 2. You can as well have 8 divided by 4. That is also going to give us 2. Then you can have 16 divided by 8. That is also going to give us 2. Then 32 divided by 16. That is going to give us 2. So you can apply it anyhow. You can start from the fifth to the fourth, fourth to the third, depending on you. But I made use of the second and the first, so to make it easier, since we all have the. So it's the sixth term we're looking for. So Tn equals a r raised to power n minus 1. Then T6 equals to 2, open bracket. That is the a is 2, the r is 2, then the n is 6 according to the parameters written here. The n is 6 minus 1. So you are going to solve the power first. So 6 minus 1 is 5. Then after solving the power, then you saw what is attached to the power before you work on this. So 2 raised to power 5 is 32. How did we come about 32? We came about it because 2 is multiplied 5 times. So that means 2 times 2 times 2 times 2 times 2. So that's 2 in 5 places. So 2 times 2, the first is 4, times 2 is 8, 8 times 2 is 16, then 16 times 2 is 32. So you have the 32 written in brackets, then 2 multiplies 32, because the relationship between this and what is in the bracket is multiplication. So 2 times 32, that gives 64. So that is the sixth term is 64. So that's 2 plus 2, 4, 4 plus 4, 8, 8 plus 8, 16, 16 plus 16, 32, 32 plus 32, 64. Or 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 2 is 64. Then alternatively, since the sixth term we are looking for, how to derive that is Tn equals a raised to power a r raised to power n minus 1. So the sixth term is 6. So 6 minus 1, that is 5. So you can as well use this formula. That's why I made the formula. If you're not using t base n equals a plus open bracket n minus 1 into d, you can use t5 equals to a plus n, since you know the term. The same thing applies to this. If you're not using the nth term, then you can use the terms value. So since the sixth term you are looking for, just deduct 1 from the term, then put the power there. So the sixth term, take away 1 from it, then the r will be 5. Because this is first term. So if this is first, then the remaining 5 will be the r. It will be for the r. And that's why you're having r raised to power 5. And that's how to explain it to this level. So sixth term is a raised to power, a r raised to power 5. Then the sixth term equals to 2 into the r is 2. Then the 5 is the power. So 2 raised to power 5. That's 32 times 2, 64. So I'm done with the first part of the worked example with the two examples. So I move to the second one. So in this, it said, find the first and third terms of the sequence whose nth terms is n raised to power 2 plus 3. So that means the nth term of the first term and the nth term of the third term. This is the value that you're going to use for each of them. So the sequence is to be derived. That is, you are looking for the first term and the third term, but they've given you the formula, kind of. So the formula that you're going to use. So let the nth term of the sequence be. So you're using this as the formula for it. Nth term equals n squared plus 3. So write out the parameters. Only the n you're looking for. The first one is first, then the next one is third. So n here is 1, then in the next one, n here is 3. So when n is 1, that is Tn equals to n raised to power 2 plus 3. So that's T1 equals to, instead of n, you put in 1. So when you plug in the 1, then you have 1 raised to power 2 plus 3. Then 1 raised to power 2 means 1 times 1, which is 1. Then plus this 3, and that gives 4. So the first term is 4. Then in this one, we are looking for the third term because it said find the first and third terms of the sequence. So the third term is what we're looking for. So that's n equals 3. So Tn equals n raised to power 2 plus 3. So T3, which is third term, equals to, instead of n here, you plug in 3. So 3 squared plus 3. Then 3 squared is 9. 9 plus 3, that gives 12. So the third term is 12. So if you're going to check it out now, so that simply means they're doing something like addition of 3 when you square the first. So if you check it out, this 4 is the first term. Now we're trying to check from this formula now. So if the first term is 4, then what is going to be the second term? So that means the second term is going to be 7. That is, so what they are now doing is it's looking like they will do 2 raised to power 2 plus 3. That is 4 plus 3, that is 7. So 4 plus 3 is 7. So what you'll be adding is addition of that makes it look like a rule, addition of even odd numbers, rather addition of odd numbers. So you have 4 here, plus 3 is 7. 7 plus 5 is 12 because this is first term. And the second term will be 7. That is 4 plus 3 is 7 because everything you're adding 3 to it. Then the next one is going to be 7 plus 5 is 12. Then 12 plus 7 is 19. 19 plus. So if you check it out, the first term they added 3. The second term you had 5. The third term you had 7. The fourth term you had 9. The fifth term you had 11. And that's what you'll be adding according to this formula. That's what the formula states. So if you want to get as many terms as possible, then you check it out as it continues. And that's that. So we're done solving the work example. So you need to try this. Find the next two terms. 100, that is 100, 96, 92. Then this and this. Then 20, 10, 0. Then the third one, 1, minus 2, 4, dash, dash. Then find the first and second terms of the sequence whose nth term is 3n minus 5 over 4. So that's what you are going to try. Then you have an assignment, which is find the next two terms. Number 1, 4, minus 1, minus 6, minus 11, minus 16, dash, dash. Then 2, 5, 8, 11, 14, dash, dash. 4, 8, 16, 32, 64, dash, dash. Find the fourth and sixth terms of the sequence whose end term is. So you find the first and sixth term of this. Find the first and sixth term of this. So you're going to find two terms for this one, and that's fourth and sixth for only this. Then fourth and sixth for only this as well. And that's it. So I think we need to quickly take one or two answers from this first part before we move to series.
Hello, Ebenezer. Please, are you still there?
Yes, Mercy, he wants them to take the assignment. At least let's have one or two persons. You can attempt and give us your answer, one or two persons, and then we proceed to the next, following the already explained formulas. So please try.
Okay.
And share your answer. You can unmute and let us know what your answer is, or you can share it in the chat room. Attempt the classwork, the one that has try these. Am I correct, Beniza?
Yes. That's the first and the second. Yeah.
So find the next two terms. Find the next two terms. You have 100, 96, 92, and then find the next two terms. Once you have your answer, please unmute and let us know, or you can put it in the chat room.
Okay, Ebenezer, you have some answers. You have an answer from Oluwasegun
Okay.
in the chat room. Yes, please.
Okay, Oluwasegun for the first, second, third. There are four questions there. Number one is Roman figure 1, 2, 3. Then number two is just two terms, first and second term. Okay. Is that the only person who has submitted? I hope this person did try this.
All right, Ebenezer. So I think we should continue. I
Okay.
don't even know if they are actually doing this. So let's continue, please.
Okay.
Thank you.
Yes. All right. So for Jano, Solomon did tried, got the second one and the first one. That's the Roman figure 1 and 2. That's what Fojano did. And that was correct. But for Oluwasegun did assignment instead. So let's progress. All right, class. In order not to waste our time, maybe during break we can keep trying some other questions. So for Jano did well for the first Roman figure and the second Roman figure 196.92, then 2010.0. For Jano got the first and the second, but waiting for the third and number two. While Onioluwasegun did assignment instead of the try this. So this assignment is meant for you to take away to do why you should try this now. So let's move to the next, which is series. So in series, a series is when the terms of a sequence are added together. This simply states that series is obtained by adding together the terms of a sequence. Take note, in sequence, you have 1, 3, 5, in and so on that way. But in series, when all these terms in the sequence are added together, so when you have the 1, 3, 5, in sequence, then in series you have addition sign in the middle, that is plus. So that's what differentiates them. In sequence, you differentiate each term by comma, while in series, you differentiate each term with an addition sign in the middle. So a series is when the terms of a sequence are added together. This simply states that series is obtained by adding together the terms of a sequence. So a series may be infinite, take note, carrying on without end. Like this example one, 1 plus 3 plus 5 plus 7 plus dot dot dot. That is infinite series. It doesn't have end. It carried on without end. Or finite, which contains a definite number of series. Definite number of terms. So in this Roman figure 4, you have 2 plus 6 plus 18 plus 54 plus dot 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 plus 1458. This is a finite series. Reason, it has an end. Why these other ones with triple dots at the end, they do not have end. The number 5 also has an end. So you have 3 minus 15 plus 75 minus something that dash up till 7th term. So immediately you get to the 7th term, you stop. That is also a finite. So Roman figure 4 and 5 are finite series. So 1 plus 3 plus 5 plus 7. If you check all these numbers, they are the numbers that we talked about on the sequence. So it's just to put addition sign in the middle to make them series. So anytime they are talking about series or sequence, please note in sequence you have comma, playing its role by separating the first term from the second, while in series you have addition sign in the middle. So the formula for series, for the sum of a series, is this is S base n. That is sum of a series. That is sum of nth term, or sum of n equals to n over 2. This n over 2 is the same thing as half n, because in some books you may see something like 1 over 2n, that is half n. So instead of me doing that, I have to multiply the 1 by the n. So you have n over 2, open a parenthesis, 2a plus open bracket n minus 1, close it, into d. Or simply put, the sum of the series equals to n over 2 into a plus l. Now, if you check all of this, they have the interpretation which is below this box. Now, sum in the other one, this one is for arithmetic progression. That is things that has to do with when you have difference given, or you have last term given in a particular series where the difference between the first and the second term is known, second and the third term, third and the first term is known. That's when you have this formula used. Then this second one is arithmetic progression. So in arithmetic progression, you have this, which is sum of the series equals to a, open bracket, 1 minus r raised to power n, close the bracket, all divided by 1 minus r. Then, or the sum equals to a, open bracket, r raised to power n minus 1, close bracket, all divided by r minus 1. Now, take note in this place here. I specifically did not put the difference between this first one under the arithmetic regression and this. The reason is here you have 1 minus r raised to power n, all divided by 1 minus r. But here you have r raised to power n minus 1, all divided by r raised to power n minus 1. I mean r minus 1. Now, in this first one, anytime the ratio is less than 1, this one is used anytime the ratio is less than 1. So if you have half, for instance, 1 over 2, that's less than 1. This is the ratio, this is the formula you're going to use. When you have 0.99, this is the formula you're going to use. The reason is the ratio is less than 1. But anytime the ratio is greater than 1, then use this formula. So that means if you have something like 1.1 or 1.01 or 1.09, then use this. So far there is 1, and or you have 1 whole number 1 over 11 or 1 whole number 3 over 4. For the fact that the ratio is greater than 1, then use the second formula. But if the ratio is less than 1, use this first formula. So from the two formulae in the patch above, Sn is the sum, A is the first term, N is the number of terms, then that is nth term, then L is the last term, D is the difference, and R is the ratio. Those are the letters that are in this formulae that you can find in this patch. Now let's take a look at worked examples. So under illustrations on series, we have worked example. Find the sum of the series, the Roman figure 1 and 2. So we'll be solving them together here under it. So you have 2 plus 6 plus 18 plus 54. And the second one is 50 plus 49 plus 48 plus dot 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 plus 2 plus 1. All the number of terms in this place, there are 50 terms. If you check 50, 49, 48, 47, 46, 45 down to 1. So that means there are 50 terms there. So this just to indicate by putting in a bracket for you to understand. And this kind of series is a finite series because the number of terms are known. You have from first to fourth term. This second one also is a kind of series that the number of terms are known, which are 50 terms. All right. So we're not working with the infinite series. So that's I didn't put that in there. All right. So for the first one, 2 plus 6 plus 8 plus 54. It says find the sum of the series. What this is saying is you should add all of this together. Now, since you have a very short one, you can just add them straight up. Adding them straight up simply means you go by 2 plus 6, that is 8. 8 plus 18, that is 26. 26 plus 54, that is 80. So simple and straightforward. That's what they ask you to do. Find the sum of the series. Now, the reason for the formula is if you have a very large numbers, you have say 2 plus 6 plus 8 plus dot 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 plus 100,000. Are you going to be adding it 2 plus 4 plus 6 plus 8 down till you get to 10,000? That's going to waste your time. So in order for you not to waste time in doing that, then a formula is provided. Now, if you check this, this is not uh it's not having a difference. Even though if you look at the first and the second, we say 6 minus 2, that's 4. What about 8 minus 6? 18 minus 6. Is it 4? No, it isn't. So that means there is no difference in this first one. So what you are going to use is ratio. Now, how do you know? 6 divided by 2 is 3. 18 divided by 6 is also 3. 54 divided by 18 is also 3. So in order for us to solve this, then write out the parameters. So the parameters will be A is 2, then N, number of terms, 1, 2, 3, 4. There are 4 terms there. Then the ratio is 3. And here I said R is greater than 1. How did we get ratio as 3? You say 6 divided by 2. That's 3. Or you say 18 divided by 6. That's also 3. Or you say 54 divided by 18. And that's also 3. So the ratio is 3. And if you check now, 3 is greater than 1. It's obvious. So R is greater than 1. That means the ratio is greater than 1. So in order for us to do that, you do the one that says sum equals to A into open bracket R raised to power N minus 1. Since the R is greater than 1, so it's R raised to the power of N minus 1 close bracket all divided by R minus 1. So you can now plug in the values. Substitute 2 for A, you have 2 here. For R, you have 3 there. Then for N, you have 4. So instead of A, you have 2. Instead of R, you have 3. Instead of N is 4 minus 1. So this is R minus 1. R is 3 minus 1 is 2. Now to solve this, start with the one with power. 3 raised to power 4. That means 3 multiplies itself in 4 places. That's 3 times 3, 9. 9 times 3, 27. 27 times 3 is 81. So that's why you have 81 here. 3 raised to power 4 is 81. Then minus 1. If you subtract it, 81 minus 1, that gives 80. So you see you have the 2 outside. 3 minus 1 under, that gives 2. So 81 minus 1 is what you have here. Then 3 minus 1, that is 2. So 81 minus 1 is 80. Then the 2 is here, 2 is there. This 2 cancel this 2. That's what you have in here. 2 cancel 2. Then the answer is 80. So the sum of the 4 terms in the series equals to 80. As we have said there, if you check 54 plus 6, that's 60. 18 plus 2, that's 20. 60 plus 20, that gives 80. So that makes that easy to understand. That's why I use smaller numbers, then at the same time, I use the formula to derive the same answer. So if you have a large number, you don't need to be adding one after the other. What you need to do is check out for the parameters what a is, what n is, what ratio is, then you plug in the formula and derive your answer. So move to the second one. 50 plus 49 plus 48 plus this dash dash to plus 1. The first term is 50. So if you check the next is you're having what is called the number of terms from the first to the end. The number of term is 50. So A is 50. The first term is 50. The number of terms from 50 down to 1 is 50. Then the last term is 1. And that's why we're using this formula. If you check, if I go back a bit, see the one that has, sorry. So this one here, this is the formula that we're using. Sum equals to n over 2 into first plus last term. So because we have last term and we have first term, we have number of terms, we're using this. So I think being we do not have it, then we can just use this formula like this. So even if you use this, you're going to get the same answer. But to make it faster, that's why I'm using this. All right. So n over 2, open bracket, first plus last term. So since we have, if you are going to use the one with difference, 50 and 49, that's 49 minus 50, that's minus 1. So you are going to use minus 1 in the formula. That's the first formula, which is n over 2, open bracket, 2a plus, open bracket, n minus 1 into d, close the bracket. That one, you are going to use minus 1 as your difference. But to make it faster, we have first term, we have last term, then we have number of terms, then we use this. So the sum of the 50 terms is going to equals to 50 over 2. That is n is 50, then divided by 2. Then first term is 50 plus last term is 1. 50 plus 1 is 51. Then 50 over 2 is 25. So 25 times 51, that will give us 1,275. If you are not too sure, just add from 50 straight down to 1. 50 plus 49 plus 48 plus 47 plus 46 plus 45 plus 44 down to plus 1. You're going to have this answer as a final answer. And that's the first worked example that we have here. Then the second one, find the sum of the first 6 terms of the series. 80 plus 81 plus 82 plus ... So this one didn't have end, but they told us the first 6 terms. So the other ones can continue, but you're adding 80, 81, 82, 83, 84, 85. So you're adding from 80 to 85. So if I'm to add orally, I'll just say from 80 to 85, that's 6 terms like that. So 8 times 6, that's 40, that's 480. Then 1 plus 2 plus 3 plus 4, that's 10 plus 5, 15. So that's 15 plus 480. That simply means 495. So I've added them orally. But in order to make use of the formula, just write out the parameters. For the first one, A is 80, the first term is 80, the second term is 81, the third term is, so the first term is 80. What's the number of terms? They told us 6. You write 6 there, that's for n. Then what's the difference? 81 minus 80. Always, anytime you want to find the difference, is the second minus the third minus the second, the fourth minus the third, the fifth minus the fourth. Don't do first minus second. You do second minus first. All right. So the difference is 81 minus 80, and that gives us 1. Now that we've known the parameters, let's plug them into the sum because they say sum. So the formula for sum is n over 2 open bracket 2a plus open bracket n minus 1 into d. So in order for us to solve this, you plug in n, which is 6. 6 over 2 is what you're having here. Then the a is 80. That's 2 into open bracket 80 plus. Then the n is 6 Minus is minus, 1 is 1, close the bracket is the, then the difference is 1. Then you close the parenthesis. So 6 divided by 2, that's 3. Then you have all these repeated. 6 minus 1, that is 5. Then all the other ones repeated. Then 2 times 80, that's 160. The 3 is repeated. 2 times 80 is 160. Then 5 times 1, that is 5. So 160 plus 5, that's 165. So 3 is outside. 3 multiplied by 165. 3 times 5, 15. 3 times 6, 18 plus 1, 19. You write 9, you keep 1. So 3 times 1, 3 plus 1, 4. So the sixth term, the sum of the 6 terms is 495. When you add all the numbers here to the 6th term, you have 495. And that's what that says. Now the second one says the 6th term also here is what we're doing, 45 plus 30 plus 20. So if you check this now, this one here is AP, arithmetic progression, while this one is GP, is geometry. Geometry in the sense that it's ratio that's going to work here. The second divided by the third. So if you say 30 divided by 45, that's going to give you 2 over 3. Why? 30, what goes in 30 and goes in 45 is 15. 15 here is 2, 15 here is 3. So if you check from here now, 20 divided by 30, 0 cancels 0, that's also 2 over 3. And the next number also divided by this. That's how it continues like that. So what we are asked to do is we sum up all the values here if you continue. So writing out the parameter, A is 45. Then how many terms are there? 6. N is 6. Then the ratio is 2 over 3. The second divided by the third. The first divided by the second. So you plug in all this into the formula. The formula is, oh, I didn't put the formula in here. So the formula is Sn equals to A into 1 minus, open bracket, or just say A into 1 minus R raised to power N, close bracket, all over 1 minus R. That's the formula, which is what this one here is the formula that ratio is greater. Why this one here is the formula that the ratio is less than 1. So 2 over 3 is not up to 1. Before you can get 1, you have 3 over 3. So since it's 2 over 3, that means it's less than 1. So we are using the formula, the opposite formula of this one that is here. So the A is 45, open bracket, 1 minus, open bracket, 2 over 3, all raised to power 6, close the bracket, all divided by 1 minus 2 over 3. 2 over 3, all raised to power 6 is 2 raised to power 6, 3 raised to power 6. That's what is interpreted here. Then you have all the other ones in place. Then we move to the next. 2 raised to power 6 is 64. That's 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2 is 64. That means 2 in 6 places, that's 64. And the next one is 3 raised to power 6. 3 raised to power 6 means 3 times 3, 9, 9 times 3, 27, 27 times 3, 81, 81 times 3, 243, 243 times 3 is 729. So they have 2 raised to power 6 are 64, 3 raised to power 6 are 729. So you now do 1 minus 64 over 729. To make it easier, you can just say 79 times 1, 79, minus 64. That gives you 665. So that means 9 minus 4 is 5. 12 minus 6 is 6. Then you borrowed 1 from here, 6 minus 0 is 0. So since this one that is there, multiply this by this, then subtract this one from it, it will be over this. That's what you're having here. 665 over 729. Open and close bracket, multiply by 45. All divided by 1 minus 2 over 3. So the 1 minus 2 over 3 still coming to that. So we divide what goes in here. If you check, 9 goes here. 9 in 45 is 5. Then 9 in 729, that's 81. 9 in 72 is 8. 9 in 9 is 1. So 5 is here. 81 is here. So if you multiply 5 times 665, you have 3,325 over 81, because this one divides to give the 81 here. Then 1 minus 2 over 3. 3 times 1, 3. minus 2, that's 1. So that's 1 over 3. That's what you have under. So if you divide it, this one divided by this, that's when it's interpreted this way. Now that you have division here, when it comes to the next level, you invert. When division becomes multiplication, the numerator becomes the denominator, then the denominator becomes the numerator. So the 3 goes up, the 1 comes down. And that's what you're having here. So as soon as that happens, then you can now divide. So 3 goes in here. 3 in 3 is 1. Then 3 in 81 is 27. So that's 3,325 times 1 is 3,325. Then 27 times 1, that's 27. So 27 is 3,325 is 123. If you use your calculator, I guess by now you should have calculator with you. So 27 in 3,325 is 123. Then it has a remainder of 4 divided by 27. If you use your calculator and you get decimal, there is a place, if you're using a scientific calculator, just press the S to D, SROD. It should take you to improper fraction or mixed fraction. So that's the worked example on that. Then try this, do this at your own leisure time. Then maybe during break, you can quickly attempt those ones. Then you get back to us on the space, on the chat space. Then you take this one home as your assignment. Maybe you get back to the school if you want the answer to those assignment questions. So we're done with sequence and series. We can go straight to time value of money. So simple and compound interest. We're moving on. The time value of money, TVM in short, is the concept that the sum of money is worth more now than the sum will be at a future date due to its earnings potential in the interim. So its concept is based on that the naira you have today is worth more than the promise or expectations that you will receive a naira in the future. This concept, let me quickly explain some things here. This concept can easily be applied when you're saying time value of money. It can be applied to what is happening in Nigeria today. Everybody's saying things are expensive and all that. So if you check the money that you have, in fact, let me not go too far. 2023, before this administration resumes, and now that the administration is on, it's incomparable. If you have 10 million that time, now your 10 million will be like, say, divided by 2, 5 million. And why did I say divided by 2? To make it easy and understandable. As at that time, dollar was, if I say divided by 2, it's an understatement because it's even worse than that. But let me just use that as an example. The amount of dollar to a naira as at then was 600 to 700 naira. But now dollar is 1,700. So that means it's more than 2. If you say by 2, that's like 1,004. So somebody who has 5 million that time, no, that who has 10 million that time, is very rich. You have 10 million. So if you are going to check how many dollars are in your 10 million, it's very easy to calculate. Just check using your calculator. Then let's say it's 700 naira. So that means your dollar is worth 14,285.71 or 770 or thereabout. So if you have $14,285 then as your 10 million, if that money is kept somewhere, so that means by today the value has gone down. That's what time value of money is telling you. So if you have kept that money since that time as naira, in this time, that is, you kept it as 10 million naira, which can earn you $14,285. You're now keeping it till this time. So that same 10 million naira that you're having or that you had as at then, if you divide it by the 1,700 that you have today, now it's 5,882. So what time value of money is saying is the money that you have now is worth more, is far. is far or is worth more than what you will have in the future dates. So those that were in that time, as at that time, it was your present. Now is your future. So you have 10 million that time kept somewhere, and you are claiming that you're a rich person. And that your 10 million was worth 14,000 plus in dollars. But now that same 10 million is worth 5,882 in dollars. So that simply means many of us now, we are wanting to, or we want to go back to the past simply because it was better than what we have now. So its concept is based on that the naira you have today is worth more than the promise or expectation that you receive a naira in the future. So money that you hold today is worth more because you can invest it and earn interest. So if you have 10 million that time, or let me say it's now, let's even leave that time. So you have 10 million naira now. It's better for you to invest the 10 million naira, earn your interest now, than for you to keep the money now and be waiting for magic to happen in the future and you be happy that you have money. Because as the day goes by, as time goes on, your money is reducing in value. So that's what it means in essence. So after all you should receive, after all, you should receive some compensation for going spending. So that means any money that you don't spend, maybe you give it to the bank, for instance, you are supposed to get some interest on it. But what interest are you getting from bank? You have, say, 100,000. They are giving you interest of 200 naira, 500 naira. That's not money. But some people may be money. But you are getting 1,000 naira for 100,000 naira. But if you invest the 100,000 naira to a very lucrative business, in a matter of weeks or months, you earn bigger money or you get bigger interest. But keeping in the bank for a year, you know how much you're going to earn. So there is something you expect to receive. That is what that line is saying. You should receive compensation for foregoing spending. So if you decide not to spend the money, if you decide not to use the money to do something, whatsoever that money is with you presently, there's supposed to be something like compensation that you should get from it. So you keeping it in the bank, you're supposed to get compensation for leaving the money there because the bank is going to use it to make some more money. So they use the money kept with them to generate more funds for themselves. So they invest it to do this, to do that. So the time value of money is a core principle of finance. So the time value of money is also referred to as the present discounted value. For instance, you can invest your naira for 1 year at a 6% annual interest and accumulate 1.06. So that means your 1 naira, if you invest 6%, if you invest it for 1 year, you're supposed to get, for that 6% now, 1 naira 6 kobo at the end of that year. So you can say that the future value of the naira is 1 naira 6 kobo, given a 6% interest rate and a 1 year period. So it follows that the present value of the 1 naira 6 kobo you expect to receive in 1 year is only 1 naira. So that simply means your future should be better than your present. Simply put, your future should be better than your present. But in Nigeria of now, the future is worse than the past, simply put. So the concept used in TVM are, that is time value of money, are interest. The interest has to do with simple and compound interest, then future value and present values, then annuities, loan amortization, and sinking fund. In all of this, we'll be looking at simple and compound interest, we'll be looking at future value, we'll be looking at present values, then maybe we'll look at the formula for annuities. Then we leave out loan amortization and sinking fund. But mind you, inflation has a negative impact on the time value of money because your purchasing power decreases as price decreases. As price rise. So when there is inflation. There is negative impact of inflation on time value of money. And that simply means that what you can buy will be reduced as the price is going up. Check it now. Beans used to be 2,500 naira for a plastic of beans. Last year, early last year, late 2022. So late 2022, then early 2023. Beans used to be one plastic, let's say 2,500. Now it is 12,500. So that simply looks like the thing has multiplied by 5 times. So that's like 500% increment. So because of that now, people that used to buy, take for instance, that's my favorite food. I love buying beans a lot. So the money that was used to buy one plastic then, or the money that will be used that was used to buy 5 plastic is now being used to buy 1 plastic. That's 1 pint of beans. So the purchasing power has reduced. In order for you not to follow the pattern that you have been following in the past, then you have to watch how you spend your money. So the negative impact inflation has had on beans is that I could buy 5 paints with the money that I will use now to buy 1 paint. So instead of me to now go and buy 5 paints, so that means if I'm going to buy 5 paints, 25, 50, that's like 62,500 for 5 paints. Then I'd rather buy 1, or possibly I'll just buy a Derica or buy 3 or 2. So that means the purchasing power, the money that I supposed to use to buy enough had gone down. Because what? The price of that thing had gone up. So when the price of items go up and the money that you use in getting those things are going down, then there is inflation. So that inflation is now causing the worst side of impact on money or the time value of money. Checking what the time value of money is saying. What you have today is far more than what you have tomorrow. So time value of money by somebody, he said, time is more valuable than money. A quote by Jim Rohn says you can get more money, but not more time. So you can get more money, but not more time. And that is simply saying that you can keep working to get more money. As you're getting more money, you're getting older, the time for you to accumulate more than that is reducing. Before you know, the energy is not there anymore. Before you know, the person is gone. So you can't have more time, but you can have more money. So in order for you to get more money, then you need to work harder today. So the time value of money concept is telling us anything that you need to get now, get it now, invest it now, make your money now. Because at a future date or future time, that thing would have been worthless. So we move to the next, simple interest. Simple interest is the earning on an original amount invested. That's the interest that you earn on money that you invest in a business. So that simply means that whenever you're investing money, you're expected to get an interest at least. If you put money to do one thing, there is need for you to get interest. And that's what simple interest is saying. So earning an original amount invested in business. So the original amount of money that you invest in business is called principal. So that principal is what earns you simple interest. So the principal and the interest payments remain the same from period to period. So that is the principal and the interest payment remain the same from period to period. Take note of that. The principal and the interest, that is the interest that you get on that principle. They remain the same from period to period. That's in simple interest. So when you get to compound interest, it's a different ball game entirely. So simple interest is a method of interest that always applies to the original principal amount. That's the original amount that you use in starting a business. Now, let me simply put, principle in this sense could mean a lot of things. When I get down a bit, then I'll explain what it is. So, method of interest that applies to the original principal amount with the same rate of interest for every time cycle. That is simple interest. So when we invest our money in any bank, the bank provides us interest on our money. So the interest applied to the banks are of many types, and one of them is simple interest. That's what the bank pays, simple interest. It's so simple that if you have 10,000 naira in the bank, at the end of the year, you will see your interest as 1 naira 4 kobo. And every month they send you a lot debit amount, 4 naira for commission, 2 naira for clinical charges. Before you know it, they removed like 10, 15, 20 or 30 or even 15 naira from your money, if not more than. But at the end of the year, they'll be giving you a ridiculous amount as interest. So the interest paid by banks basically is simple interest. It's simple because it's simple and it's minute. Simply put. Now, before going deeper into the concept of simple interest, let us first understand what the meaning of loan is. So a loan is an amount that a person borrows from a bank or a financial authority to fulfill their needs. Now, that money that you collect from a bank or the money that you collect from a financial authority, it's not even only a bank, it's not only financial authority. You can get a loan from even an individual. You can go to somebody and say, please, loan me a certain amount of money. In order for you to get more later, there is need for you to add something to it. Take for instance, I go to a person to collect a certain amount of money. If the person was feeling reluctant to give it to me, and maybe we didn't promise ourselves that I was going to pay an interest on it. But by the time I collect the money, it takes for instance 50,000 naira. When I'm returning it, at least I return it maybe 50,500 or 51,000 or possibly 52,000. It depends on my needs that money meets at that time. If it meets something that gives me more money, then I can add more money to it so that next time when I go to such a person, the person will easily give it to me because something will definitely climb on it. So that is also a loan. So an amount of money that the person borrowed from a bank or a financial authority to fulfill their needs. And I'm adding mine by saying it could also be an amount of money that is borrowed from an individual just to meet a need. So loan examples include home loans, car loans, education loans, and personal loans. So a loan amount is required to be returned by the person to the authorities on time with an extra money. So when you collect a loan or when you obtain a loan, you need to return it with extra money, which is usually interest you pay on the loan. So that extra money that is paid on that money that you obtained, that you collected, that you borrowed, that is called interest. So I put below, I said simple interest is simple unless you made it not to. So it's simple except you made it not to. We move on. The formula for simple interest. Simple interest is calculated as follows. In some call it SI, some call it I. Depends on the one that you want to call it. You want to call it SI, which is simple interest. You want to call it I, which is also simple interest. And the formula is SI equals to PRT over 100. P simply means principal, R is rate, T is time, divided by 100. Or check in some books, you see it as SI or I equals to PRT. If you check the first formula, this formula says PRT over 100. Why this one says PRT? The R here is rate, and rate is always in percentage. As I said here, where R equals to R percent, and R percent simply means R over 100. So if it is R over 100. So that means P times R over 100 times T. So P times R times T is PRT, then over the 100. That's what it means. So if you see somebody putting it this way, the person is right. Anybody puts it this way, it's also right. Any of the two, correct. Now, where P is principal, R is rate of interest in percent per annum, and T is time, usually calculated as the number of years. Now, principal is the amount that was initially borrowed as loan from the bank or invested. The principal is denoted by P, and the formula for P is P equals to 100 I over RT. So it was a subject of formula that was there. They make P the subject of formula just to get the 100 I over RT. So if you carry this R put here now, to make it the subject of the formula, the P will go there. That's R equals 100 I over PT. If you carry T and put here now, the P will come down. That's T equals to 100 I over PR. So, and that's what is translated in others. So principal is the amount that was initially borrowed as a loan from the bank or invested. And the rate is the rate of interest at which the principal amount is given for someone for a certain time. So as the rate of interest can be 5%, 10, or 13%, and so on. So the rate of interest is denoted by R. R equals 100 I over PT. Time is the duration for which the principal amount is given to someone. Time is denoted by T. T equals 100 I over PR. Then the next is amount. When a person takes a loan from the bank, take note of this, please. If you check very well, amount is not stated under this, but now I'm explaining something about it. When a person takes a loan from a bank, he or she has to return the principal borrowed plus the interest. And this total return is called the amount. So that means when you borrow a certain amount of money, you borrow 10,000 naira, you're paying interest of 5%. So for, let's say, for 1 year. So the 10,000 naira plus the 5%, 10% of 10,000 naira is 1,000. So 5% is 500 naira. So you are returning 10,500 naira. Now the 10,500 naira, that's that you are returning to the person, is called amount. Why? Because they added the principal, the 10,000 you borrowed, and you're adding the 5%, which is 500 naira, that is to be paid to the person as interest. You add the two of them, which is 10,005, and you give to the owner. That is called amount. Then if you calculate just the 5%, that 500 naira, that is simple interest. But if you have that 500 naira, which is the simple interest, to the amount to the money that you borrowed, then the name given to that is called amount in under simple interest. So the formula for amount is denoted as A equals to principal plus interest, which equals to principal plus the interest is PRT, or remember PRT over 100. So let me just use PRT to manage the space. So P plus PRT. P is principal. The interest, the formula is PRT, as you can see up here. That is P plus I. That's what gives amount. To break it down, in case they did not give you interest, that is in the statements that you want to use to solve your question, interest is not there, then they will give you principal rate and time. Very easily. You see that you calculate interest and add it to principal to get amount, or you just use the principal rate times time, then you add it to the principal. So the principal rate times time plus principal now gives us P. P is common, bring it out. So P divided by P, that is 1. Then P divided by P is 1, is out. So remaining RT, that's what you have here. So P into 1 plus RT, and that is the formula for amount. You see that P plus I, P plus PRT, or P into 1 plus RT. That's the formula for amount under simple interest. Then amount equals P plus I. So if you transpose the formula, or you make the other letter the subject of the formula, from A equals to P plus I, then P will equals to A minus I, then I equals to A minus P from this same formula. And you're good to go. And that's what that is. Then if you do that, then this I here, this I can also be interpreted as PRT, blah, 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 just to get other formula. So that's for the simple interest formula. Then illustration. You need to try this on your own. But before you do that, you need to write out the parameters. A trader borrows illustrations now. A trader borrows 70,000 naira at 5% for 3 months. What is the interest? Or what interest would he pay on the money at the end of the period? This question is wrongly framed, possibly during typing. A trader borrows 70,000 naira at 5% for 3 months. So for 3 months, the person is to pay 5% on 70,000 naira. If it goes beyond that 3 months, you are going to be paying extra percentage or charges on it. So what is the interest, or what interest would the trader pay on the money at the end of the period? So this one here now, you write out the parameters. The 70,000 naira is your P. This 70,000 naira is the P. That's the principal. The R is rate. Then the T is 3 months. That's the time. So this time is not given in year. So you have to translate it to year. And how do you do it? 12 months make 1 year. So 3 months out of 12
Ebenezer,
months,
please.
that's going to be. Okay.
Hello, Ebenezer.
Hello, ma.
Please, can we see the illustration? Your slide is not moving.
It's not moving. How?
The illustration you are talking, yes, now. Yes, you are on it now.
Okay.
And then please check the chat room. You have a question.
Okay. Let me quickly do that, please. Okay. This is the question. What interest formula does the Ponzi schemes use? Is it the simple interest formula or the compound interest formula? Okay. Somebody said, I have a question, and the question is, what interest formula does the Ponzi schemes use? Is it simple interest formula or the compound interest formula? Basically, I would say the Ponzi scheme, they don't really use any of this. They don't use simple interest, they don't use compound interest. They use the participation of, or what would I call it now? Their audience. Maybe I should call them audience, or those people that are partaking in it. They use the activities. Good. So that, I think that's the best word to use. They use their activities to determine the interest that will be used, to give those that that partook in the event. Take for instance, should I use X Empire for instance? Like X Empire, like what's the name of this? Amstar. They didn't use simple interest, neither did they use compound interest to calculate it. The reason is there's an assumption to them that you are not spending money, even though indirectly you are spending money. And sometimes they even ask for tokens to be spent by people. Sometimes they ask for tokens to be spent by people. They will tell you to buy tons. They will tell you to play games. They will tell you to watch videos. All of these things, they are indirect way of collecting money from you. For you to get a ton, then you need to go buy it. And in order for you to buy a ton, then you are spending money. So buying a ton should be about 4 to 5 or 6,000 naira for 1 ton. Then that's like maybe $2 or $3 or thereabouts. There's a way the thing is being calculated. So it is the activities, let me put it that way, the activities of those that are participating in the event that they use to determine how they share the money. So they don't use compound interest, they don't use simple interest. None of this formula is applicable to Ponzi schemes. They use activities the participating activities of the participants before they used to determine it. They will tell you get 10 friends, get 5 friends, get 1 friend. 1 friend will hand you a certain number of coins. Maybe 10 friends will hand you another certain number of coins. Then you see some people, they have 5,000 friends. You see some 10,000 friends, some 0 friends. There was one I participated in, maybe in Amsterdam. I think I only had 1 friend. At the end of the day, Amsterdam didn't request for money, but there are some games that they did and all that I played. You know, at the end of everything, I think I got $15 like that. So there was no, interest or formula sharing ratio pattern that they used to get that. So it's just your activities that determine. And all that. So you will want to outdo others by continuing to play the games just for you to acquire more coins. So to the extent that they introduced key, some people will generate keys, you will play the games. So basically they don't use simple interest or compound interest. So they use the activities of the participants, to determine their formula sharing ratio. And that's what they use in, accruing money to people. So they use it to share the money to those that participated in their games. And that's the answer to that question. Then for this illustration, I didn't really put the work in. I would like people to, use the formula to get this. That's why I'm stating it. So for this illustration, there is no working on it. It's so easy. Just apply the formula, you get your answer. So that's why I'm saying that a trader borrows 70,000 naira. So for the 70,000 naira is P. Now I will go back to the formula. Principal is 70,000 naira, except you just want me to just quickly do something on it, which is we just say P is principal, which is 70,000 naira. That's 70,000 naira to the principal amount of money that the person got on it. That is, sorry, the principal amount of money that either the person borrow or the person invests. That's what that one is saying. So the principal is 70,000 naira. Then you have the next one, which is the rate. So you go for rate is 5%. But when you are showing your workings, you don't need to put the symbol percentage there. Then the time. The time is 3 months. So these 3 months now, in order for you to work it, what you need to do is you convert it to year. So 3 months is 3 out of 12. So that is 3/12. And that's what you're going to use to solve your question. So for the formula now is interest you are looking for. Say, what is the interest that will be paid on the money at the end of the period? So the formula for the interest equals to PRT over 100. That's PRT over 100. So that's the formula for the interest. So in order for you to do this, it makes it so easy. Then this PRT over 100 equals to, what is P? 70,000. 70,000 times R. What is R? R is 5%. Then times the month. The month is 3/12. So that 3/12 is going to be 3/12. Then everything over, that will be everything divided by the certain amount of percentage that is there, which is divided by the 100 under it. So everything that you're having here divided by 100. So if I'm to do that, this is what I'm going to have. So everything here divided by 100. So 100 is going to be the division value. So sorry, I'm just working on this now because somebody asked me to do that. So that's this. So this is 3 over 100. Mm-hmm. Division sign. So the 3 over 12 will be here. 12 is under, 3 is up. Then I can remove this. So this is what you're going to have. So PRT over 100. So that's 70,000 times 5, then times 3 over. So what you need to do is 3 here is 1, 3. 3 in 3 is 1, 3 in 4. 3 in 12 is 4. So 4 divides the 70,000. So the 70,000 divided by 4, that will definitely give 17,500. So that would be 17,005 times 5 over this. Let me just complete it instead to make it easy. So I repeat this. Sorry. What's happening? So 3 in 12 is 4. 3 in 3 is 1. Now, this 4 divides the 4 divides the 70,000 naira. So I'm still going to have something like, if 4 divides, 4 here is 1. 1 is already up. Then 4 in this, 4 in 70,000. That gives 17,500. If you're with your calculator doing that. So these 2 zeros, we cancel the 2 zeros under. So you're having 175 divided by 100. So 175 divided by 100 then times 5. So finally, your answer is going to be 875 naira. That will be the simple interest. 875. That's the simple interest. So for this question, this is going to be the answer. 175 naira. 875 naira. And that hence that. So I didn't put it because it's a simple task to work with. So I can easily undo all of this that I've just done and continue with my analysis. All right. So I continue the explanation. So a trader borrows 70,000 naira at 5% for 3 months. What interest? What interest will be paid on what interest will be paid on the money at the end of the period? And that's 875 naira. Okay. So the next is a man invested certain amount of money. So I can make the slide big now or bigger. A man invested certain amount of money which amounted to 650 naira simple interest at 6% for 5 years per annum. Find the sum. In this case, you have been given in this context that that man invested certain sum of money which amounted to this. So 650 naira is the amount in simple interest at 6% for 5 years per annum. Find the sum. So this simple interest, this 650 naira is the simple interest. That is I. You're going to plug it in for the question that is in. It says you should find the sum. So this is the simple interest. This is the rate. This is the time. So you are looking for the sum. The sum in this case is the principal. And that's what that is saying. So you use the formula for principal to derive your final answer. So the formula for principal equals to, see formula for principal. Principal is 100I over RT. That is 100 multiplied by simple interest divided by rate times time. Then the third one is Chioma took a loan of 1,200 with simple interest for as many years as the rate of interest. If she paid 432 naira as interest at the end of the loan period, what was the rate of interest? So in this case, you are expected to use a letter to determine the number of years that the person paid, because the number of years is not stated. So you're not going to get a real answer from this. You're going to get an answer with a variable. And that's what this illustration is saying. So I don't have the solution to this with me. If you want me to get you this solution, I can just solve it. Maybe I'll send it to the school, then they'll forward it to you, the students. But if you want, the comprehensive explanation on this, then maybe there's going to be a different class for it entirely. Because I just needed to make the explanation very fast. That's why I had to skip some things, basically. So sorry for that. Then the next is compound interest. Compound interest is the periodic interest earned on the principal plus previously earned interest. So the principle of compound interest being paid on the principal plus reinvested or retained interest. So we said in simple interest, the money is simple. It's just the money that is earned. Basically, at the end of the year or termly basis, 3 months, 6 months, quarterly. So it depends. And any amount of months that is given to you in simple interest, you count it and rate it over 12 to get your time. But in compound interest, the money that you get in the first year is what you compound with the same interest in the second year. You compound it, the answer that you derive from there also, you compound it with the same interest for the third year. So the principle that you derive in first year, you will compound it with the rate of interest to get the second year. It will give you another principle. The principle that you get for the second year, you compound with the previous rate of interest to get another principle for the third year. Then that's how it continues like that. That's why it states that is the periodic interest earned on the principal plus previously earned interest. So the principal or compound interest being paid on the principal plus reinvested or retained interest. That's what the compound interest is. So compound interest is the interest calculated on the principal and the interest accumulated over the previous periods. So it is different from simple interest, where interest is not added to the principal. So in simple interest, they don't add interest to the principal. Anytime you add interest to the principal, you have an amount, and that's it. So when you add interest to principal in simple interest, it's only amounts that you get. But in this, you calculate the interest during the next period. That is in compound interest. The interest, you use it again in the next period with the newly generated principal that you have. So compound interest is usually denoted as CI. So compound interest finds its usage in most of the transactions in the banking and finance sector and other areas. So basically, it's in banking and finance that you can make use of compound interest. Now, some of its applications are: one, it increase or decrease in population. That is, you apply it to whether the population increases or the population decreases. They also apply it to the growth of bacteria. You apply compound interest in the rise or depreciation in the value of an item. All right. So the compound interest is mostly commonly used. That is commonly used concept in our daily existence. That's the most commonly used concept in our daily existence. So suppose we observe our bank statements, we generally notice that some interest is credited to our account every year. So when you check your bank statement, the one they send to your email address, That's the comprehensive one. That's where you can get it comprehensively. It's only in your email. It won't send to you in a SMS. It's not comprehensive. So the bank statement is generally noticed to have a credited amount to your account every year. So this interest varies with each year for the same principal amount. So the same money that you have this year, the interest that you will get at the end of the year will be different from the interest you will get next year for this same money that is still there. So if you leave your money in 2023, the interest that they got at the end of 2023 will be different from the interest that will be gotten at the end of 2024, still based on the same money. So if you have 10,000 naira in 2023, you get interest of 5 naira at the end of 2023. In 2024, that 10,000 naira is still there, but your interest maybe will now be 6.5. That is compound interest because they continue to compound it every year. And that's how the thing will be going up and up and up. And that's why it's compound interest. So it can be compounded annually, can be compounded monthly, can be compounded quarterly, can be compounded semi-annually, can be compounded daily and continuously. So compound interest could be done in any of these ways. So the formula below can be used to find the amount. Amount in compound interest though. So amount equals to principal into 1 plus r% raised to the power of n, or amount equals to principal open bracket 1 plus r over 100 raised to the power n. So r% is the same thing as r over 100. So this formula is used when it is compounded annually. So that means n is number of years, r is rate, then P is principal. Then amount equals to principal open bracket 1 plus r over n all raised to power nt when it is compounded daily, weekly, monthly, quarterly, semi-annually, and so on. So that's when you have this one here to be used. So that simply means r over n means the rate. If the rate is 5%, so the 5% will be converted to decimal. That's going to be 0.05, all divided by the n. N is number of times that thing is compounded in a year. So if it is semi-annually, that means 2 times in a year. That's when they compound it. So for the n will be 2. Then the t will now be the time it is compounded. So this one will now be P is principal. 1 plus R, if it's 5%, 0.5 will be up. If it's done 2 times in a year, if it is, say, monthly, so this one, this n will be 12. This n will be 12. Then if it is for 5 years, that will be 12 times 5 will be the power here. So this n will be 12, then it is number of years times. Then compound interest equals to A minus P, that's amount minus principal. This is the formula for compound interest, this one here. Now, this same formula is broken down. This A for amount. This is the formula for A here. P into 1 plus R over N all raised to power NT. This one here is what you put in here. So it's this one here that is plugged in now. A is for amount. So instead of A, they put in this value here now. They put minus P. It's A minus P. Sorry, just a minute. Okay. That break. I'll be back. So we'll be going on break by 12. And Thereafter, we'll continue when the break is over. I think it's 30 minutes break or thereabouts. So by 12, we'll be going on break. So let me quickly round off this. So the compound interest is A minus P, that's amount minus principal. So the formula for amount is this, and that is what is plugged in here, because this one is expanded to this. P, that is P into 1 plus R percent raised to power n. So instead of A, that's what is put in here. Then the minus P straight ahead is what will be here. So that is P into all of this minus P. P is common, is brought out. Then remaining 1 plus R percent raised to power of n, then minus 1, you close it. Or CI equals to P into, when you are making use of this second formula here, P is common, is brought out, open a parenthesis, then 1 plus R over 100 raised to power n, then minus 1. You close it. So compound interest, when it's expanded for this second one here, and this is the formula to be used, P, open parenthesis, open another bracket, 1 plus R over n, close it, raised to power n raised nt, then minus 1. So if you open this, it will be this times this. That will be something like this. Then P times minus 1. That is P. That's minus P. So if you check it, since this one represents A, then the P that is there is this, then the minus will be there. So that's what this translation simply means. So expanded compound interest formula when compounded daily, weekly, and so on. And this one is expanded compound interest when it's compounded yearly. Now the formula interpretation. A is amount, that's future value. P is principal present value, rate of interest or interest rate. Then N is number of years, that's periods. Then in the second formula, A is amount of future value, P is principal or present value, then R is rate of interest or interest rate. And the R here will be in decimal. That's why I put it in bracket. Then N is number of times interest is compounded per year. Then T is times, which is in years. So if it's 5 years, then if it is monthly in 5 years, it's each month in 5 years. So that's going to be in a year now. This is going to be 12. Then if it's 5 years, this will be 5. So 12 times 5, that's 60. That's what this is saying. Then CI, compound interest equals A minus P. And that's what is translated to this. And this same one is translated to this. Why this one is translated to this, according to what I explained at the previous end. Then where CI is compound interest, A is amount of future value, P is principal or present value, then R is interest rate in decimal, N is number of times interest is compounded per year, then T is times in years. Now, the interpretation of key ideas helps to identify all the letters in a formula. So that's the essence of this interpretation. Then, real-life application of compound interest. Real-life examples of compound interest calculations with annuity tables. The first one is compound interest is good for retirement savings. It's good for mortgage payments, investment returns, and car loans. So in real life, you can experience compound interest in retirement savings, mortgage, investment returns, and car loans. Then the examples of compound interest that can be found in actions, you can see it in savings accounts. You can see compound interest in stocks and bonds. You can see it in certificates of deposits, and you can see it in retirement accounts. Then the real examples of compound interest at work: retirement savings, debt payment, repayment, investment in the stock market, real estate investment. That's where you can find it at work. Then the examples of compound statements in programming language. You have it if else statements, for loop, while loops, try catch statements. So for those who did programming, they will understand this aspect better. Now, compound interest as a kind of cycle. that can be identified from this narrative. Now look at it. If you check this cycle now, you have the money that you earn from initial investment. That money that you earn in initial investment, you will reinvest it. So when you reinvest the money, you will get, now see the dotted line. When you reinvest it, the thing goes like this. Then you get something, the amount of money that you have today, that's this. Then you have interest on it. Then your interest continues to increase, continue to increase the money. That's how your money will keep growing. So you have a certain amount of money, the money that you earn, you reinvest what you earn again. When you invest it, you will earn another money. When you reinvest it, you will earn more money. When you reinvest it, you earn more money. And that's how the cycle continues to rotate. So this uh, cycle now states that the most powerful force in the universe is compound interest. So that simply means when you invest your money in compound anything, and when it's compounded, either monthly, weekly, biannual, semi-annual, or annually, or yearly, depending on the terms to be used, then continue to get more money. And I think at this point, before we go to this illustration, I'd like to take a break. We'll be back, say, in 30 minutes time. Thanks for your audience.
Thank you so much, Ebenezer.
All right.
Please, we can go on a 30 minutes break. We'll be back at exactly 12:30. Thank you so much. Please do not go far.
Thank you.
All right, everybody, you're welcome back from the break. It's good to have you back on the call. Okay, Ebenezer, please, you can take it over from here. We are back from break.
Okay.
Thank you.
You're welcome. Okay. You're welcome back, everybody. Now let's continue from the slide we stopped. So lastly, I said the most powerful force in the universe is compound interest, because you make interest, you invest it, you make, you invest. As you're investing your money, you are getting more money. So that is why it is said that it is the most powerful force in the universe. So let's take a look at an illustration. We're taking one out of these three, so you can give a shot on the other questions and possibly get back to us. Thank you. So the illustrations. 13 years ago, Upom invested a sum of 540,400 in a savings program which has consistently yielded 5% per annum compounded monthly. How much should be in Upom's account now, and how much interest has the savings yielded so far? The second question says, how much will have to be invested to give 250,000 naira after 8 years with 10% quarterly compounded? Then the third, a bank offers 5% compound interest calculated on half-yearly basis. A customer deposits 1,600 naira on 1st January and 1st July of a year. How much would he have gained at the end of the year by way of interest? Note, before you solve any question, please write down the parameters. This will enable you to tackle the questions using the right approach. E.g., calculate the interest paid on a fixed deposit. The interest paid on a fixed deposit of 25,000 naira, which is invested for a period of 3 years at 12% interest per annum. Now, in this case, interest is paid yearly and invested. The interest is paid yearly and invested. Just a minute, please. Sorry for that break. Yes, I said the interest is paid yearly and invested. Now let's quickly solve that. I said before you start, you need to write out the parameters. Now the parameters are the compound interest. We don't know what it is because that is what we are looking for. I said calculate the interest paid on a fixed deposit of 25,000 naira. So the compound interest is what we're looking for. Then we have the principal, we have the rate, and we have the number of years. So the amount for the formula is 25,000 naira. That is the principal. Then the rate, that is 13%. So that's going to be 13 over 100. Then the number of years is 3. So if you are to compound this, you will have 1 plus 13%. 13% is the same as 0.13. So that's 1 plus 0.13, that is 1.13. Everything raised to the power of 3. So if you raise this one to the power of this, use your calculator, you have 1.442897. Then after getting this, you multiply this 25,000 by 1.442897, then you get 36,072.428, which is the amount is approximately equal to 36,072 naira 43 kobo. So this is the amount, but you are asked to calculate the compound interest. So I want everybody to do that, maybe just to put the answer in the chat box. So you will use the formula for compound interest, which is the compound interest equals to amount minus principal. Compound interest equals to amount minus principal. So for those that will do it, let's say in the next 30 seconds or 1 minute, just put your answer in the chat box to be very sure. So the compound interest, that's immediately after the amount calculation that has been done on the screen. So below it, you say compound interest equals to amount minus principal. So amount minus principal. So that's 36,072 naira for the 3 kobo minus 25,000 naira. Whatever the answer that you derive using your calculator, please send it to the chat space. Okay, while we're waiting for that, so let's continue. Okay, some people have supplied their own answers. Let's quickly check. Mm. All right, let's go on while we wait for the response of the compound interest answer. So the next is annuity. An annuity is a series of equal sums of money paid as regular intervals of time. So annuities are common in economic life. House rents and interest payments on money invested are all examples of annuity. So an annuity is a contract between you and an insurance company in which you make a lump sum payment or series of payments and in return receive regular disbursements, beginning either immediately or at some point in the future. Basically, the goal of an annuity is to provide a steady stream of income, typically during retirement. Many aspects of an annuity can be tailored to the specific needs of the buyer, in addition to choosing between a lump sum payment or a series of payments to the insurer. You can choose when you want to annuitize your contributions, that is, start receiving payments. So an annuity that begins paying out immediately is referred to as an immediate annuity, while one that starts at a predetermined date in the future is called a deferred annuity. I repeat, an annuity that begins paying out immediately is referred to as an immediate annuity, while one that starts at a predetermined date in the future is called a deferred annuity. So the duration of the disbursements can also vary. You can choose to receive payments for a specific period of time, such as 25 years, or for the rest of your life. Of course, securing a lifetime of payment can lower the amount of each check, but it helps to ensure that you don't outlive your assets, which is one of the main selling points of annuities. I want to re-emphasize that annuity helps to ensure that you do not outlive your assets. So that means those assets of yours that you have, you are supposed to leave them behind for the enjoyment of others. That's what it simply means. So you do not outlive it. Those assets outlive you. So that means that they are going to continue to exist while you are gone. Because if your assets are gone while you are still existing, what are you there to enjoy? The suffering continues. But in order for, those assets to be, still being intact or still continue to exist, to be enjoyed by other people around your family members and your entire environment, that thing can benefit, then this needs to be taken into consideration, and that is annuity. So that is equal payments that is paid at regular intervals of time, and this could be a lot of things: interest payments, house rents, and all those. So the main selling point of annuity is to ensure that you don't outlive your assets. Your assets outlive you. I move on. So annuity is a series of regular payments made over a set period of time. How does it work? You pay lump sum, make regular payments to you. That is, when you pay lump sum amount into your insurance company, then that insurance company makes regular payments to you at different times like that. Then lottery winners can choose to receive prizes as annuity. Then when payment starts, immediate annuity starts right away.
Why do you push easy?
So immediate annuity starts right away. Deferred annuity start later. So that means when you're talking about immediate annuity, it starts immediately. Anytime you get involved in it, it commences immediately. Why the one that is deferred? It's set to start at a particular time in the future. So life insurance, that is, take for instance, during somebody's death, the beneficiary receives a lump sum. The person that is supposed to take it after the demise of a person, the person receives it. So we're looking at life insurance versus annuity. Then this life insurance benefits is to be received periodically, depending on how the agreements are made. So the key takeaways in annuities are insurance contracts that promise to pay you regular income immediately or in the future. And a deferred annuity has an accumulation phase followed by the disbursement. That is, that accumulation phase followed by disbursement is annuitization phase. So an immediate annuity converts a lump sum into cash flows from day one. So you can buy an annuity with either a lump sum or a series of payments contributed over time. Then also, annuities come in three main varieties. It could be fixed, it could be variable, it could be indexed. Then each with its own level of risk and payout potential. So the income you receive from an annuity is typically taxed at regular income tax rates, not long-term capital gains rates, so which are usually lower. So an insurance contract issued and distributed by financial institutions with the intentions of paying out invested funds in a fixed income stream is a very good example of annuity. So take note, a lump sum is a single payment of a large amount of money rather than several smaller payments made over time. That's the meaning of lump sum. The single payment of a large amount of money. That's a lump sum. That's what you pay. You pay that lump sum. That's first payment from a big amount. So you have to pay 100,000, for instance, then you pay say 20,000 naira. That's the lump sum. That's what lump sum is. That single payment of a large amount of money rather than the several smaller payments made over time. Good. So that's what lump sum is. Then annuity is usually paid annually at the end of the year. If a person has an annuity of 70,000 naira, it means that the person receives 70,000 naira every year. So the amount of an annuity is the total of the sums of money if they are invested immediately they are received. So when you receive that money, that sum of money or the total amount of money, immediately you invest it, then that is referred to as the amount of an annuity. Then examples of annuity are regular deposit to a savings account, monthly home mortgage payments, and monthly insurance payments. Annuities are also classified by the frequency of payment dates. So the payment, which is the deposit, may be weekly, monthly, quarterly, annually, or at any other interval of time. So we quickly look at types of annuities. We have plenty types, a lot of annuities. We have immediate, deferred, income, variable, fixed, index, and many more annuities. But be taking a look at two out of many annuities. So we'll be looking at ordinary annuity and annuity due. So ordinary annuity is an annuity whose payments are made at the end of each period involved. It could be present value or future value. Then an annuity due is an annuity that is paid at the beginning of each period. It could be present value or future value. Please take note. Ordinary annuity is an annuity whose payments are made at the end of each period involved. So that simply means that anytime they are talking about ordinary annuity, you will look out for when it is to be paid. If it's paid at the end of that period, that is ordinary annuity. Then as soon as that annuity is paid at the beginning of the period, then is annuity due. So annuity due is the one that is paid at the beginning of each period, while ordinary is paid at the end of each period. Now let's take a look at annuity formula. Ordinary annuity for future value. To calculate future value of ordinary annuity, the future value is the measure or amount of how much a series of regular payments will worth in the future using a constant interest rate. It is calculated thus: FVA ordinary, that is future value of ordinary annuity, equals to A or C or PMT. Any of these three symbols or letters can be used. Open a parenthesis, 1 plus r raised to power n minus 1, close it, all over r. Or F equals to M, the F is future, so M is the payment. Open a bracket, 1 plus I raised to power nt minus 1 over I, all in enclosed parentheses. Now I'll be explaining all these letters later. Then the present value tells how much money that is required at present to be able to provide a series of payments in the future. using a constant interest rate. So it is calculated thus. PVA ordinary, that's present value of ordinary annuity, or equals to A is amount, or PMT is payment. Open a parenthesis, 1 minus open bracket 1 plus R, all close bracket, minus raised to power minus N, all divided by R. Close the parenthesis, or the payment equals to the M. That is, sorry, the present value equals to the M. M simply means payment there. Open a parenthesis, 1 minus open bracket 1 plus I, close it, raised to power minus NT over I, all in close parenthesis. Then annuity due, the future value, the same definition. Measure or amount of how much a series of regular payment will worth in the future using a constant interest rate. That one is calculated as FVA due equals to A or C. A is the amount, or C is the cash flow or the payment made. Then open a parenthesis, 1 plus R raised to power N minus 1 over R, all close bracket, open another bracket, 1 plus R, close it. If you check this formula, they are a bit different from themselves. Check the future value of ordinary annuity. There is no smaller bracket or 1 plus R, but it's the same thing. That is FVA equals to A or C or PMT, open parenthesis, 1 plus R raised to power N minus 1 over R, close. That is for ordinary annuity, which is this. Then when it comes to the future value of annuity due, there is 1 plus R by the side. That's what differentiates them. Then this other R that I'm putting is in another way. That's the other way in which it could be calculated. That is, in this first one, you have number of years given. So it's compounded every year. But in this one that you have NT given, then you have I. This I simply means it is rate over the number of times it is compounded in a year. Then the NT is the number of times compounded multiplied by the number of years it is compounded. That's what that one is saying. So the same thing happens in this case. You have that repeated formula, but you have 1 plus I there. So the R here simply means the rate. Then the I here means rate over number of times it is compounded in a year. So if they say every month, so that is going to be 12. That is 12. That's what it's going to be. But if it's going to be every year, if they say 2 years, if they say 2 years or 3 years, then use this first formula, which is just going to be the number of years. So the rate is the only thing that will be here. But when it comes to this one, that's going to be the rate divided by the number of times it is done in a year. Then the present value, the same definition. Then the PVA equals to PMT, payment, into 1 minus open bracket 1 plus I. If you check it, raised to power minus NT, all divided by I. It's the same thing with this. The only difference there is 1 plus I is also by the side. So that's what is actually differentiating both of them. And that is the formula explanation. So pick a formula and make it yours. So you can use the first one or the second one as the case may be. Then you apply it to solve ordinary annuity question or annuity question. Now let's quickly move to network. A network is a group of 2 or more computers or other electronic devices that are connected to exchange data and share resources. So there are many types of networks, including local area network, wide area network, metropolitan area network, home area network, telecommunication networks. Then you have wireless local area network, you have storage area network, you have personal area network, you have the enterprise private network and virtual private network. So any of this formula here can, any of these acronyms are the types of networks that are available. So briefly, let's look at local area network. A network that connects computers and devices in a limited geographical area, such as a home, school, or office building. So LANs are characterized by higher data transfer rates, and a limited geographical range. Then the wide area network. which is one. A large network that connects computers and devices that are physically far apart, often using telephone lines or radio waves. Corporations and international companies may use WANs to provide a common network for remote workers. The third is metropolitan area network, a data network designed for a town or city. That's man. The home area network is a network contained within a user's home that connects a person's digital devices. So this one is basically in the home. And telecommunication network, a system composed of electronic devices and communication equipment that allow the exchange of information in different formats. And these are the types of network. Now let's take a look at the one that really concerns us, which is business networking. So we've looked at network. So you can't separate. They don't live in isolation. The network and business networking, they work hand in hand, because you can't do business without many of these networks, aside from some other networks that we need to look at. So business networking is the practice of building and maintaining relationships with the other businesses and professionals to create mutually beneficial connections. Take note. Practice of building and maintaining relationships with other businesses and professionals. So when you maintain or when you build relationships with businesses that are alike or that are not, with professionals, so that you can have a mutually beneficial connections, whereby something will connect you that you benefit from one another. The goal basically of business network is to create a network of contacts that can help you achieve your business goals. So you need business networking so that you can achieve your business goals. And that's why you hear referral here and there. When somebody refers somebody to another person, maybe you are good at plumbing and somebody connects you to somebody who needs the plumber, then you are getting involved with what is called business networking. Somebody who is a digital graphic artist is connected to somebody who needs the service of that person. That is business networking. So when you build relationship with professionals, or when you build relationship with businesses, or you maintain relationship with businesses or professionals, so that you can have beneficial connections, that is called business networking. Now, other types of business networking. Why it is stated other types of business networking is because demand, that is metropolitan area network, wide area network, all of those networks, local area networks, and home area networks, and so on. They are all types of business networking. And they've already been mentioned under networking or under network. That's why this one is saying other types of business networking. So those ones to belong to this class. Instead of repeating them, let's just look at the other types. So one is online networking. At least you can connect yourself online, YouTube, Facebook, Twitter, Instagram, all of those, they're online networking. You can get professionally connected, you can get business connections all through the social online networking. Then community service clubs. If you are in one club or the other, like Lions Club, Rotary, etc., all of those ones, you can be part of it. There are types of business networking there. You can have business events. Maybe a workshop is organized somewhere like that. Then you have industrial speaking and seminars. That's also a business networking platform. Then you can have roundtable events. There can be networking of businesses there. In trade association, all those trades, hairdressing, barbing, plumbing, etc. When they meet, they connect themselves to different other businesses. That's networking. Then when workshops are organized, also networking. Then higher education lectures. And you go to higher institutions and you receive lectures from there. The students or learners that are there, that are part of that time, that part of the lecture at that time, they can interact with one another just to know what this one is doing, maybe your participation in class. All of those things bring about networking, and it will bring about business networking as well. Then you can as well have chain networks. That means when this one recommends you to do something, you recommend somebody else. That's being connected from one person to the other. So that's the kind of chain networking. They can have casual or strong contact networks. You can quickly recommend somebody casually, the person goes, person does this kind of thing for so person, and that ends it. Then some people can recommend you to go and do one or two things, and they appreciate what you've done. They get your contacts and maintain the relationship with you. That's a stronger, business networking. So these are all the other types of business networking aside from the ones that we mentioned here: plan, one, EPN, PAN, and so on. So we look at business networking organization. One of them is social media, a digital way to network with platforms like Facebook and Twitter being popular for job seekers. That's a social media business networking organization. Then you can have community service clubs. So the groups that focus on community service rather than referral networking. Then the trade shows, fundraising events, and professional association events. In person, in all these events, present events that can help you build a network. That is in-person events. That is, the in-person events is telling us that when people organize, trade show, and they organize fundraising events, when professionals meet at the association level, these are in-person events that you can connect to yourself physically, one-on-one. And this can as well help you to build a network. And while building network, your business relationship will move on from there. Then online courses or classes, like the one that we're having presently. It's an online course that everybody's participating in. So it's a way to build a network. So sometimes the people that partake in the lecture will want to get a reference from the organizer due to one thing or the other that they've achieved during this lecture or through this platform. Then that is an online courses or classes business organization network. So it's a way to also build a network. That simply put is a network is a group of two or more computers or other electronic devices. So it's not only computer that can be networked. When you connect plenty computers, if that means you are networking them, somebody can share resource from this system to the other system. The same way it's relating to when human beings connect. By the time you connect with this person, this Taiwo connects with Kehinde connects with Dada connects with Ejiofor connects with Musa. Before you know, they will ask, they will get to know themselves and know the kind of work each and every one of them is doing. Before you know what is happening, they interact, they talk about how they can connect their own ideas and experiences and the knowledge they've garnered over the years just to build the business. That's what business networking organization is all about. So we have the social media, the community service clubs, the trade show, fundraising events, and professional association events, online courses or classes. Now move to the next. Understand investment appraisal, the necessary test and application to business. Let's look at discount and cash flow techniques and some problems in it. Discounting techniques. What is discounting? Discounting is the process of determining the present value of a payment or a stream of payments that is to be received in the future. So the present value of a payment or stream of payment that is to be received in the future. So that means whatsoever that you have, you have been asked to do, how much is in it for you? How much is in that thing for you? So given the time value of money, $1 is worth more today than it will be worth tomorrow. So discounting is the primary factor used in pricing a stream of tomorrow's cash flows. So for you to determine tomorrow's cash flow, you need discounting. So in order to grow any business, every company follows the discount techniques. These techniques are made to increase the sales in the business as well as create a new customer base for the company. This helps the company to increase the amount of new customers and new benefits to the old customers. Moreover, these techniques calculate the cash there is no value for an asset except that asset can produce the flow of cash in the future. If that asset cannot produce the flow of cash in the future, it's of no use. So you look at the difference. Sorry, stock pay dividends, bonds pay interest, and projects provide investors with incremental future cash flows. I'm coming from the angle of from a business perspective. When you have an asset and that asset does not have any value, there is nothing like cash flow in the future. But if there is value attached to that asset, then you are going to have the cash that will be flowing in the future. And this could as well be explained using stocks. When you talk about stocks, when you buy stocks, you're going to be receiving dividends on it. When you buy bonds, they will pay interest on it, and projects will provide investors with incremental future cash flows. So all of these are referred to as your assets. Stock is an asset, bond is an asset. The project that you are involved in is also an asset. So what we're saying in essence is when you buy stocks or you buy bonds, for stocks, you get dividend as cash flow in the future. When you buy bonds, you get interest as cash flow in the future. Then when you engage in a project, that project will also give you money in the future. That is incremental future cash flows. So the value of those future cash flows in today's terms is calculated by applying a discount factor to future cash flows. So the difference in value between the future and the present is created by discounting the future back to the present using a discount factor, which is a function of time and interest rates. Now, a bond can have a par value of $1,000 and be priced at 20% discount, which would be 800 naira. I mean $800. So that simply means when they remove the 20% discount of 1,000, 20% discount of 1,000 is 200. So the $200 is removed from the real value of that bond. Then you the money left is going to be $800. So the investor can purchase the bond today for a discount and receive the full face value of the bond at maturity. So the difference is the investor's return. Now, types of discounting techniques. One is event-based discount. This type of discount are very common in the market. Many brands follow this type of discounting. Excuse me. The sale in this discount continued for a duration of 2 to 3 days at a very good discount rate. For example, the Big Bazaar sale of fruit juice, wherein the reputative brands come together for the biggest sale. So that is telling us that the event-based discount, you find this one in the market. And when this type of discounting is done, the sale is continued for a duration, either to 2 or 3 days. That's when they will tell you, come to so venue. We are putting our tent there. We are setting our stand. Come and buy this and that at a certain amount of money. That is event-based discount. Then when it comes to discount for special groups, in this type of technique, the company focuses on the consumer group and provides a discount for the whole year, such as discounts on army officials, school kids, pregnant ladies. So you are in a barrack. They said, okay, if your child attends our school, barrack school for instance, this is a certain amount of money that's going to be. Definitely all those schools in the barrack, the military, they have a certain discount that is given to them because the children belong to the military that has evidence of proof, or that has evidence of proof that the person is in the military. Then their children also, they will get it. Their wife, they will get it in the hospital, like that. So that's for discount for special groups. Then stock credit or subscription credit. The company can also reward their customers with stock credit and subscription credit. This type of technique is different from the traditional techniques in which the customer gets a reward in return. So this one, take for instance, Go TV. They will tell you, if you subscribe from so so date to so subscription credit, then cash discount. In this technique of discount, the business owner gives a discount on the base price to the customer who is paying in cash. So, however, this technique is used to generate cash flow in the business and reduces. Pay your bill in cash in 10 days, then you will have a discount of 2%. Yes, there are some companies that do that. When a certain amount is paid in a, then they'll give you, like, I remember when Governor Body was the governor of Lagos State. He did something like that for those who paid their land use charge match. You get a certain percentage with reduction of amount of money. That percentage is the discount given to you from January to March. Then if you don't pay it, when March ends 31st, on the 1st of April, you pay the full amount of money. So if your land use is expected to be 50,000 and you be given discount of 15%. So that simply means you're expected to pay your money between January and March. If you don't pay it, you're going to pay the 50,000. But if you pay it, that 15,000, sorry, 15% will be deducted from that 50,000. Then you own 15%, then the balance is given to them. So the next is exclusive membership discount. This kind of discount is a step above other kinds of techniques. In this, customer gets a special customer discount by attaining a premium membership. These people get an exclusive discount on the products because they have purchased a good amount of products from the company. For example, in a gym membership, the owner offers premium. As the owner offers premium offers such as personal training sessions, gift shop credits, health drink offers, and more. Now, this one is membership discount. Because you are a member of that gym, then you are entitled to a certain percentage of discount, or a certain amount that will be given to you as discount. But if you don't belong, maybe you hear that so gym, let's say transformation gym, is giving 5% to people and you are not a member, you now want to become a member to enjoy. Definitely you have become a member to enjoy. If you are not a member, you can't enjoy it. So you can't just go to the gym and expect them to give you those benefits. You can't get the benefit except you belong there. Then also, refer a friend. It's also a discount. Refer a friend discount means that when a friend buys a product from the company with the reference code of his or her friend, the friend gets a discount on it. Good. So this refer a friend is also referral in Ponzi scheme that somebody asked in the question in our earlier class. So that's referral. That's what they call it. So it could be referral, or you call it refer a friend. So in this case, when you refer friend in that Ponzi, for instance, you'll be given, let's say, maybe 1,000 coins or 500 coins or 10 coins or 20 coins or 50 coins, depending on how they are distributing their coins. The same is applicable to discounting. So refer a friend discount means that when a friend buys a product from the company with your own reference code, you give them a code that person is your friend, then the friend gets a discount on that thing. For example, once Ola refers someone to buy a company's product with his reference code, Ola's friend gets a discount on the item he purchases. So that's what Ola is going to benefit, for using his friend's code to get that thing. Then discounts on social media. Social media is the hub of advertising and marketing, and the discounts available on social media are known as social media discounts. This type of technique will not only help the customer to be satisfied and happy, but also encourages the customers to purchase more products. So that means by the time you get your discount on social media, it's when they advertise or do something, you are not only going to benefit because you did that, but you are also going to be satisfied and happy. And this satisfaction and happiness will encourage you to tell other people that, come and buy from so person, or come and buy from so space, so company online. This is what you stand to get. So a higher discount indicates a greater level of risk associated with an investment and its future cash flow. So that is to advise you, when you are getting discount that is higher, then you stand to take some risk. In one angle of your mind, let it be when you're going online for some items. It's a risk you are taking. Black Fridays, and it's not talking to many things to do. So we're done with types of discounting. Now let's go to cash flow. How much a business or spend in total over a period of time. That's why they call it cash flow. How much comes in, how much goes out. That's how it's flowing. So cash flow is typically broken down into cash flow from operating activities, investing activities, and financing activities on the statement of cash flows. A common financial statement is one of them. Now, cash flow refers to the money that goes in and out of a business. So business taking money from sales and revenue and spend money on expenses. So revenue is money that comes in, expenditure is money that goes out. So they may also receive income from interest, investment, royalties, licensing agreements, and sell products on credit rather than for immediate cash. Now, why is cash flow analysis important? Cash flow analysis determines the amount of money available to run business operations and complete transactions. So working capital is calculated as current assets. That means the current assets could be described as cash or near cash assets, like notes receivable, minus current liabilities. So the current liabilities could be liabilities due during the upcoming accounting period. Now, the formula is well stated. Working capital equals to current assets minus current liabilities. Now, cash flow analysis helps you to understand if your business is able to pay its bills of cash to continue operating indefinitely. So long-term negative cash flow situations can indicate a potential bankruptcy, while often a sign of good negative cash flow. Then there are potential bankruptcy, there are problems that you can encounter. Then when continual positive, that's long-term negative. Then when it's continual positive cash flow, then that's a sign of good things to come. Analyze cash flow business. The maths behind a free can be complex. Large companies or those with complex finances. However, bookkeeping or accounting software, sometimes part of a larger ERP. What's the ERP? Enterprise Resource Planning. It will be like line details are FP&A professionals who spend their entire workday digging into the details of financial results, looking for patterns and opportunities to improve results. So with a powerful ERP available, that's powerful enterprise resource planning available, then much of that process is automated, and this will allow you to do more with even fewer staff when your staff are not even many. So the enterprise resource planning is like a set of people that are helping you to, manage your affairs. This ERP could be in form of humans and it could be in form of software that can help you to manage your cash, how they go out and how they come in. So you have examples like Oracle, NetSuite, your cash flow, free cash flow, and other numbers like that. Then 5 steps to cash flow analysis in business. There are major liars. Effective cash flow net income. It is a indicator of a company's ability to remain solvent and sustainably grow its operation. So when you are doing anything, aim for positive cash flow, not negative. Second, be circumspect about positive cash flow. So on the other end, positive investment cash flow and negative operating cash flow could signal problem. For example, it can indicate a company is selling off assets to pay its operating expenses, which is not always sustainable. Then analyze your negative cash flow. When it comes to investing cash flow analysis, negative cash flow isn't necessarily a bad thing. It could mean the business is making investments in property and equipment to make more products. So a positive operating cash flow and a negative investing cash flow could mean the company is making money and spending it to grow. So calculate your free cash flow. What you have left after you just and they used to pay down printers, buy back stock, or acquire another company. That's when you calculate your free cash flow. Then operating cash flow margin builds trust. So when you have the operating activity in a given period, then a positive margin demonstrates profitability, efficiency, and earnings quality. So cash flow analysis helps your finance team better manage cash inflow and cash outflow, ensuring that there will be enough money to run and grow the business. So we'll quickly move straight to the discounted cash flow formula. So the formula for DCF, discounted cash flow, is DCF equals to cash flow 1 divided by 1 plus interest of raised to the power of 1 plus cash flow 2, or divided by 1 plus interest raised to the power of 2 plus cash flow of the remaining numbers or the additional years. That cash flow 1, CF1, is the first year, cash flow 2 is the second year, cash flow N is the additional years divided by 1 plus rates raised to the power of the additional years. So the discounted rate in this CF analysis is the interest. When calculating the net present value of the investment, it represents the time value of money from the present to the future. So CF1 means cash flow for 1 year, CF2 is cash flow for 2 years, cash flow additional year, that's CFN, then R is the discount rate. Now, the cash flow formula flows in a blur. So example of DCF. When a company analyzes whether it should invest in a certain project or it usually uses its weighted average cost of capital, that's WACC, as the discount rate to evaluate its DCF. So the WACC incorporates the average rate of return that shareholders in the firm are expecting for the given. For example, 7 months to launch a project. The company's WACC is 5%. That means you will use 5% as your discount rate. Initial investment $11 million. And the project lasts for 5 years. With the following estimated cash flows per year. Now, this is the cash flow. Year 1, year 2, cash flow is 1 million. Year 3, cash flow. Using the discounted formula, calculate the discounted cash flow of the project stated. All right, so the discounted cash flow, year 1 cash flow. So if you use that formula to calculate it, the discounted cash flow for year 1, 1,381. That means if you use this, so you may not, so you just put CF1. So the CF is the cash flow, and you've been given the cash flow already. The cash flow is 1 million. You are doing the 1 million. 1 million divided by 1 plus R. So that is 1 plus rate. What is the rate? 5%, 0.05. So if you close it and you put it there, so your answer is going to be 952,380.9524. So it's approximately equal to 952,381 because it's 0.9524. So you add it to the 0.
Excuse me, Ebenezer.
After the 8. So that's it. Then
Hello?
the second year, they're going to have the power of
Sorry, please, you are breaking.
Can you hear me now properly?
Yes,
Hello?
please.
Okay.
Yes, I can hear you now. Yes.
All right. So the second year, which is the cash flow is also 1 million. You plug it into that cash flow over 1 plus R raised to the power of 2. Cash flow is 1 million over 1 plus 0.05 raised to the power of 2. When you do that, you're going to have 907,029.4785. So 4 is not up to 5. Anything from 5 upward, you round it off to 1 and add it to the previous value. So since 4 is not up to 1, that's why the answer is still 907,029. Then for the third year, it's 4 million that is going to be your cash flow. So the 4 million, I'm using my calculator to do it as you're doing yours, or maybe you're just listening to me. So that's why I'm able to get all those direct decimal values. So for the third year, it's 4 million. That is the cash flow over 1 plus rate. Rate is 0.05 to raise to the power of 3. So that's going to be 3,455,350.394. 394. That is what I have here. So 350.394. So the 0.3. The 3 is not up to 5 that you can round off to 1. That is why the answer stops at 3,455,350. So that's for the fourth year. Then the third year. Then the fourth year is 4 million also. You plug it in, but your rate now is going to have, that is to the power of 4. And that's why you have 3,290,810 as the discounted cash flow. The same thing applies to the fifth year, which is 6 million. And you have this. Now it said adding up all of the discounted cash flows result in a value of $13,306,727. That's when you add up all of this discounted cash flow. This is what you are going to have, $13,306,727. Now, by subtracting the initial investment, what's the initial investment? The initial investment is 11 million. So if you subtract 11 million from that, then you have a net present value. So that means if 11 million, which is initial investment, is taken away from the sum, the total sum of the discounted cash flow, $7, and that's what is going to be your net present value. Now, the positive number of 2,306,727 indicates that the project could generate a return higher than the initial cost. That is a positive return on the investment. So that simply means that you have something positive, you have more money in your account. Therefore, the project may be worth making. So by the time you're done with this, then you can invest in that kind of project. But if the project had cost 14 million, you know that the initial investment was 11 million. Now, let's say the initial investment was 14 million. Then the net present value would have been, that is, if you deduct the 14 million from 13,306,727, then you will have 693,272 negative. That means you're going to have a negative value. You know, the previous one we had a positive value, which is 2 million plus. Now you'll be having a negative value. So as soon as you have negative value, that would indicate that the project cost will be more than the projected return. That means what the project is worth will be more than what the project is supposed to earn you. Thus, you are not supposed to engage in that kind of project. So thus, it might not worth making. So you may not engage in such projects. So that's what discounted cash flow helps us to do. It helps us to know the kind of project we're supposed to engage in or embark on, or the project we are not supposed to embark on. So by the time you put all of this into practice, the first year, the second year, the third year, the fourth year, the fifth year, as many years as possible, by the time you have a negative, then the project is not worth investing in. But if you're going to have a positive returns, then it's worth making. And that is
Hello, Beniza, are you there? Hello? Hello? All right, please, let's exercise a little patience.
means you are only going to
We
be
lost you.
estimating.
Beniza, we lost you at some point.
Where exactly, please?
If you could go back like 2 minutes backward. Can you hear me? Are you there, please?
Mercy, I think his network is glitching
Oh,
because
okay.
Cash
his
flow
icons
example.
are no longer.
Hello?
Yeah,
Yes, we lost
Ebenezer,
you at some point.
Where exactly is that? Is it the examples of discounted cash flow?
No, you were done with this example. You were just explaining this if the project had cost 14 million or that was the point we lost you.
Okay. Yes, I said this discounted cash flow that we've done here, when you add up all the discounted cash flow values, you're expected to have $13,306,727. So when you have the total of this to be 13 million plus, if you subtract the initial investment was $11 million. If you subtract it from the 13 million, then you have a positive value of $2,306,727. That's going to be your net present value. So whenever your net present value is positive, that's where you lost it. So whenever your net present value is positive, that means that investment is worth taking. You can engage in that investment. So I now said, if the project had cost $14 million and your total discounted cash flow was 13 million plus, if you deduct the 14 million from the 13 million dollars, you are going to have a negative value of $693,272. So that will indicate that the project cost could be more than the projected return. So what you expect to get in return, the worth of that project is more than it. Then you will have a negative value, and that project might not be worth making. So you may not engage in that kind of project. So I entered into the advantage. I said the analysis, DCF analysis, can provide investors and companies with a reasonable projection of whether a proposed investment is worthwhile. So it helps you to know whether that project is worth it or it doesn't worth it. Then disadvantage is the major limitation in DCF is that it involves estimate. You just estimate it. It is not actual figures that you're working with. So you may want to invest 12 point something million now. You now assume, you estimate maybe 13 million or 15 million. So the result of DCF is also an estimate. So that means that for discounted cash flow to be useful, individual investors and companies must estimate a discount rate and cash flows correctly. Then it is an analysis that can be applied to a variety of investments and capital projects where future cash flows can be reasonably estimated. So this one is telling us that you apply it to different kind of investment and capital project that you know that the cash flow will be something reasonable when you estimate it. Then the disadvantage is the future cash flow rely on a variety of factors such as market demand, the status of the economy, technology, competition, and unforeseen threats or opportunities. So this can be quantified reliably. So investors must understand the inherent drawbacks for their decision making. Then another advantage says its projection can be tweaked to provide different results for various what if scenarios. What if scenarios is, what if I put 10,000 naira and $10,000 and I get $8,000? Is it worth it? So that if you put $10,000 and at the end of the day you are getting, let's say, net present value of $1,000, the project is worth investing on. But if you put $10,000 and you are getting a negative of $1,000, that project is not worth investing in. Why? Because your net present value is negative. So that's what this third advantage is saying, that its projection can be tweaked to provide different results for various what if scenarios. So while you are calculating it, while you're estimating it, you do some projections. What if, what if, what if? So there's going to be what ifs in your calculation just to be very certain that you're not going to make a loss. Then disadvantage says the DCF shouldn't necessarily be relied on exclusively, even if solid estimates can be made. So that means you not put all your eggs in one basket. In one basket. Don't put all your eggs in one basket because sometimes your estimates may not be reliable. So companies and investors should other consider other known factors as well as sizing up an investment opportunity. So in addition, comparable company analysis and precedent transactions are two other common valuations methods that might be used. So merits and demerits of this DCF help to give clear understanding on the use of discounted cash flow. That's what I put at the footer. Then the next is indices and logarithms. So we quickly rush into indices. So index in mass is the power exponent, which is raised to a number or a variable. For example, in number 2 raised to the power of 4. 4 is the index of 2. The plural form of index is indices. So we have been hearing indices or law of indices. What they are saying is They are talking about the plural. So the singular is index, the plural is indices. So remember that index could also mean power, and power could also mean exponent. So it's either you call it index, or you call it power, or you call it exponent. So the 2 to the power of 4, that is it, 2 and 4 is up, means 2 raised to the power of 4, 2 exponent 4. So, and 2 index 4. So that's why I said 4 is the index of 2. So that's 2 index 4, 2 power 4, 2 exponent 4. So the plural of index is indices, the plural of power is power, the plural of exponent is exponents. Now the first rule, we are looking at loss of indices now. If a constant or variable has index of O, then the result will be equal to 1, regardless of any base value. So that simply means anything raised to the power of 0 must be 1. Anything raised to the power of 0 must be 1. The only thing that is not going to be 1 is 0 raised to the power of 0. 0 raised to the power of 0 is going to give you error. You press it in any calculator. So that means it's a syntax error, or it's math error. But any other thing raised to the power of 0 is 1. So if you say transformation college raised to the power of 0 must give you 1. So an example is given, a raised to the power of 0 is 1. That's example, 5 raised to the power of 0 is 1. So 12 raised to the power of 0 is 1. Y raised to the power of 0 is 1. So all of these examples given, just press them on your calculator, you're going to get 1. So 1, 1, 1, 1 are the answers. Then rule 2. If the index is a negative value, then it can be shown as the reciprocal of the positive index rate to the same variable. A raised to power minus p equals to 1 over a raised to power p. So what this simply means is that when you have a value raised to power of something, I would like to explain it this way. If you say a raised to power minus p, you see that minus, it's going to become 1 over, only the minus become 1 divided by, then the remaining values that are there in that statement given, then you write it, that is a raised to power p. So that simply means the minus has become 1 divided by, then the a and the power p, they remain. So that's 1 over p. So if you have something like a raised to power minus 2, that's going to be 1 over a raised to power 2. So the minus there becomes 1 over, then the a and the 2, that's a raised to power 2. So if you have something like 2 raised to power minus 2, that's going to be 1 over 2 raised to power 2. That's 1 over 2 raised to power 2 means 2 times 2. That's 1 over 4. And that's what rule 2 says. If the index is a negative value, then it can be shown as the reciprocal of the positive index raised to the same variable. Then the third, okay, we have example. 5 raised to power minus 1 equals to 1 divided by 5 raised to power 1. And 5 raised to power 1 is the same thing as 5. That's why you see the answer as 1 over 5. 5 raised to power minus 1 is 1 divided by, this minus becomes 1 over, then the 5 here and the 1 here, that's 5 raised to power 1. Then 5 raised to power 1 is 5. That's why 5 is there, then it's 1 over 5. Then 8 raised to the power of minus 3. The minus becomes 1 divided by, then the 8 raised to the power of 3. So if you multiply it, 8 raised to the power of 3, very easy to do. The answer is going to be 512. If you check it, just do 8 times 8 times 8. But because it's indices, that's why the answer is stopped at 1 over 8 raised to the power 3. 3 states, to multiply two variables with the same base, we need to add their powers and raise them to that base. A raised to the power of p multiplied by a raised to the power of q. You see the dot that is used there means multiplication. So sometimes it could be a raised to the power p times a raised to the power q. It could be a raised to the power p, open bracket, a raised to the power q, close bracket. It could be a raised to the power p dot a raised to the power q. It means multiplication in this case. So multiplication in law of indices becomes power when they have the same base. There is a here, there's a here. So both of them are the same. The bases are the same. So you pick one of the a's, that's the a. Then the power, you add them because there's multiplication in the middle. p plus q. That's why it is a raised to the power of p plus q. So 5 raised to the power 2 multiplied by 5 raised to the power 3 means 5 raised to the power, pick one of the bases, the 2, then 5 raised to the power 5. And that's what that is. 5 raised to the power 5 simply is very easy as well. 3,125. That's what it is. If you multiply 5 times 5 times 5 times 5, 5 multiplies itself in 5 places. All right, that's what that is. And if you solve it individually, you're going to have the same thing. So that's going to be 25 times 125. You see have 3,125. So this is 5 squares, 25 times, then 5 raised to the power 3 is 5 times 5 times 5, which is 125. So 25 times 125 gives 3,125. And that's that. But because it's indices we're looking at, is 5 raised to the power 5. Rule 4. To divide two variables with the same base, we need to subtract the power of denominator from the power of numerator and raise it to that base. So it's been explained dramatically, but for simplicity's sake, a raised to the power p divided by a raised to the power q. If you check them, the same value is raising different powers. A is a here, then the power here is p, the power here is q. But because it's division sign that is here, even if they write it as a raised to the power p divided, like using division, normal division sign that you know, dot, hyphen, dot, is the same thing as this. So the a is the same base, so you bring it out. Because it's division sign, that is p divided by q as power. This is not going to be plus. It's going to be minus. So sorry about that. So this will be p raised to power, sorry, a raised to power p minus q. And that's that. So this is going to be a raised to power p divided by a raised to power q equals to a raised to power p minus q. That's what the rule states here. So because it's division, they said to divide two variables with the same base. So these two variables, their bases are AA, then they have different power. So the power has to be subtracted and raised to the base. So we need to subtract the power of denominator. So that is P minus Q. That is P minus Q. Then A is common, you bring it out. Now example is 10 raised to the power 4 divided by 10 raised to the power 2, which equals to the bases are the same, which is 10, then 4 and 2. That's 4 minus 2. So that's 10 raised to the power 2. If you do that directly, that's 100. And you do it from here, 10,000 divided by 100. That's still 100. So it's the same. But because it's indices, you have to write it in power. Rule 5. When a variable with some index, this should be some indices. When a variable with some indices is again raised with different index, then both the indices multiply together raised to the power of the same base. Now look at it. It said when a variable with some indices is again raised with different index, then both the indices are multiplied to
Hello, please, are you there? I think his network is bad. Please exercise a little patience. Let's get him back on the call. Thank you.
okay. What about the break? Yes, I'm on rule 5. I say when a variable with some index or some indices is again raised with different index, then both the indices are multiplied together raised to the power of the same base. Okay, so open the bracket, a raised to power p, close the bracket, raised to the power of q equals to a raised to power pq. So that simply states that when you have this one power here and there's another power outside, what you just need to do is bring this a here, then this p and this q multiply. That's p times q. That's what gives this pq. So a to raised to the power 2, open and close bracket, raised to the power of 3 equals to 8 raised to the power 2 times 3, which is 8 raised to the power 6. So 2 times 3 is 6. So the next, rule 6. When two variables with different bases but same indices are multiplied together, we have to multiply its base and raise the same index to multiplied variables. Now, what this is saying is you have different bases. A is one base, then B is another base. So these are the two variables with different bases. And when two variables with different bases, A and B are different bases, then they have the same power, the same indices. P and B are the same, P and P, the same indices with two different variables. Because they are multiplying a to the power of P times B to the power of P, then you multiply these two and combine them with one power, that is A times B, that's AB. Then since they have the same power, we bring it out. So applying it to an example, 3 raised to the power 2 multiplied by 5 raised to the power 2, that's 3 times 5. Then raised to the power of 2 outside. So 3 times 5 is 15. 15 raised to the power 2 is the answer. And 15 raised to the power 2 is 225. So 15 raised to the power 2 is 225. That's what it is. So if you are not too sure if this rule is applicable, then you can do it separately to be very sure. In case you have bigger numbers, just apply it this way, then you get your answer. So 3 raised to the power 2 is 9. Then 5 raised to the power 2 is 25. So 25 times 9 is 225, and that's what it is. Then we move to the next, rule 7. When two variables with different bases, but same indices are divided, we are required to divide the bases and raise the same index to it. Now look at two variables with different bases. You have A and B. Then you have P and P, just like the multiplication. And the P and P here, they are the same. So what you need to do is write the A over the B, then put them in the same power since the powers are the same or the index is the same. So you have A over B to the power of P. So A over B to the power all raised to the power P. So that simply means 3 over 5. That's 3 raised to the power 2 divided by 5 raised to the power 2 equals to this 3 over 5 will be written here. Since they have the same 2 as power, then you bring out the 2 as the power. So if you finalize this, if you simplify this, it's going to be 9 over 25. But because it's index or indices you're looking at, then 3 over 5 all raised to the power 2. Then rule 8. An index in the form of a fraction can be represented as the radical form. So what they're saying is a raised to the power p over q equals to the base, that is the denominator of that power, because this is a raised to the power fraction. So a raised to the power p over q. Q is the denominator there. That denominator is going to be in the root side. Then the numerator is going to be in the power side of the a. So that is q root a raised to the power p. Q root a raised to the power p, or I say q root a to the power of p, or q root to the a to the power of p. So q root or q root a to the power of p. Example is a raised to the power 3 over 4. The 4 is going to be in the root place. then the 3 is going to be the power of the a. So this is fourth root of a cubed, or a raised to power 3. Or you have a raised to power half. This one is the same thing. Since it's 2 that is there, you don't write 2 in this place. It's 3 upward that can be written here. So if the denominator of the power is 3 and above, it will be written here. But if it is 2, it will not be written. So this statement simply means a will be inside. The 2 is supposed to be here, but because it's 2, it's not always written. Then the 1 is the power. So a raised to power 1 is a. That's why it's there. So that's why this a raised to power half equals to root a, or square root of a. Now, in this problem, let's quickly apply the laws of indices to solve. Multiply x raised to power 4 by y raised to power 3 by z raised to power 2. And x raised to power 5, x y raised to power 5 multiplied by z raised to power minus 1. The solution is this x raised to power 4 and this. You multiply them all together because it says multiply. So in multiplying them all together, you're going to have something like x raised to power 4 times x, this x here, this x raised to power 4 times this x. That's what is brought together here. Then y raised to power 3 times y raised to power 5. That's what is here. Y raised to power 3 dot y raised to power 5. Then z raised to power 2 times z raised to power minus 1. So z raised to power 2 times z raised to power minus 1. So this one is x raised to power 4. This is x raised to power 1. The 1 is invincible. So when you're solving, you have to make it visible so you know it appear in your solving. So the law of indices, this law states that when you have something like this is rule 3. 5 raised to power 2 times 5 raised to power 3. That's a raised to power p times a raised to power q equals to a raised to power p plus q. The same thing applies to this. X raised to power 4 times x raised to power 1 equals to x raised to power 4 plus 1. Then this is y3, y5. That's y raised to power 3 plus 5. Z2, z minus 1. Z raised to power 2 plus minus 1. Plus minus 1 is plus times minus 1. That is minus. So that's z raised to power 2 minus 1. So x raised to power 4 plus 1 becomes x raised to power 5. That's 4 plus 1 is 5. 3 plus 5 is 8. That's y raised to power 8. 2 minus 1 is 1. That's z raised to power 1, which is also z. So that's why this is your final answer. So I move to the next example 2. Solve a raised to power 3, b raised to power 2, all divided by a raised to power 2, b raised to power 4. So if you check this, they have the same value, a over a to the power of 3, b to the power of 2, then a raised to the power of 2, b to the power of 4. So if you have to solve that, a is common up and down. So since a is up and a is down, the rule 4 states when you have the same base, different power, you subtract the power. So I go by it. A raised to power 3 divided by a raised to power 2 is a raised to power 3 minus 2. Then b raised to power 2 divided by b raised to power 4 becomes b raised to the power of 2 minus 4. That is the 2 of this b minus the 4 of this b. Then 3 minus 2 is 1. That's a raised to power 1. Then 2 minus 4 is minus 2. That's b raised to power minus 2. So that becomes AB, that is AB raised to power minus 2. So if you further this, there is a rule that says b raised to power minus something. This minus will become 1 over then the b raised to power 2. So this one will become a times 1 over b raised to power 2. So that's a times 1 is a, then b raised to power 2. That's why this is a over b2. Then the third one, find the value of 27 raised to power 2 over 3. So the power is 2 over 3. The power is only written here. The power is 2 over 3, not 2 over 4. 2 over 3. All right. So that's corrected. So 27 raised to the power 2 over 3. Don't forget, I said the denominator is going to be in the roots, which is this. This is 27, not 8, 27. All right. So I move on. So that is this 27 raised to the power 2 over 3. So 27 will be inside. The numerator is going to be by the side of the 27. Then the denominator, which is 3, is going to be in the roots place. So that is cube root of 27 raised to the power 2. So that simply put is this 27 raised to the power 2 is what becomes this. So checking out this value, if I'm to explain further, the cube root of 27, if you bring this power of 2 out, cube root of 27 is 3. So since cube root of 27 is 3, then 3 raised to power 2 is this. So cube root of 27 is 3, then the power which is 2 is there. So 3 raised to power 2 is 9. So that's why this one becomes 9. And that is as far as indices is concerned. Let's quickly move to matrix. Matrix is a set of numbers arranged in rows and columns so as to form a regular array. The numbers are called the elements or entries of the matrix. So that means all those numbers that you have inside a matrix, all these numbers now, they are called elements. We call them entries. So matrices have wide applications in engineering, physics, economics, statistics, as well as in various branches of mathematics. Matrices also have important applications in computer graphs, where they have been used to represent rotations and other transformations of images. If there are m rows and n columns, so the matrix is said to be an m by n matrix, written m times n. So the by is the times. For example, this 1, 3, 8, 2 minus 4 and 5 is a 2 by 3 matrix. How do you identify? The first row, that's 1. The second row is 2. So this first part is talking about the row. The m is the row, the m is the row. So you mention the row first. Row 1, row 2, that is 2. Then the 3 here is column. Column 1, column 2, column 3. So m by n means row by column. That is row 1, row 2, then column 1, column 2, column 3. So this matrix is 2 by 3 matrix. Then we move to the next. A matrix with n rows and n columns. No. Sorry. The matrix with m rows, and n columns is called a square matrix of order n. You have 1, 2, 2 rows, 1, 2, 2 columns. So row 1, row 2, column 1, column 2. So since the rows and columns are the same, they call them square matrix. So an ordinary number can be regarded as 1 by 1 matrix. Thus, 3 can be thought of as the matrix 3. Like this is 1 row, 1 column. So that is matrix 3. So which is 1 by 1 matrix because it's just one thing there. A matrix with only 1 row and n column is called row vector or row matrix. That is, if you check it like this, the number of row is 1 row. The number of row is 1 row like this. It said row and n columns. So n columns simply means is just 1 row. If we are to just look at this, it can be referred to as 3 columns, but because it's just a line, it's not having the next value in the next line. So it's just 1 row. You don't look at this as column 1, column 2, column 3 in this case. That's why they call it n columns. But it's going to be 1 row, 3 columns. But this is only 1 row. They call it row vector, or you call it row matrix. And the example is 1, 2, 3. It's just one row like this. Then a matrix with only one column and n rows is called column vector, or you call it column vector matrix. So this is one column like this. So you don't look at it as row 1, row 2, row 3. So this is just one column the way it is. All right. Types of matrix. As earlier explained, row matrix is one row. Column matrix is one column. Rectangular matrix, the number of rows must not equal to the number of columns. Like this one is 2 by 3 columns. That's two rows, row 1, row 2, by column 1, column 2, column 3. So 2 by 3 matrix. So that's a rectangular matrix. Then if you have, maybe you have the next line here. This one is not there. Let's say 1, 3, 2, 5, 7, 9. And it's like this. So this will be row 1, row 2, row 3. And this will be column 1, column 2. That's still rectangular. So this is rectangular matrix because it looks like a rectangle. Square matrix, all the rows must equal to the number of columns. 1, 2, 3 rows. 1, 2, 3 columns. So the number of rows must be equal to the number of columns to call it a square matrix. Then zero or null matrix. You have all the items in the matrix as 0. So it could be 1, 2, 3, 4. Maybe they just cover this like this. That is also null matrix. But the fact that all the numbers in it are 0. So you call it zero matrix, or you call it null matrix. Then identity matrix, or you call it unit matrix. All the numbers on the diagonal from the left, from the first value on the left hand side in a diagonal form down, is called identity matrix or unit matrix. That simply means one must be in here for you to call it identity matrix, or you call it unit matrix. Then the seventh one is diagonal matrix. This diagonal matrix is not one that is going to be here now, because if one is there all through, that is unit or identity. But since you have different numbers there, 1 is there, 2 is there, 3 is there, it can be 7, 9, 11, it can be 2, 5, 7. For the fact that only this line like this is constant with non-zero digits, then you call it diagonal matrix. It is not like this, but it is like this, from left down to right, they're following this diagonal. Then scalar matrix. Anytime you have scalar matrix, all the value in the diagonal line must be the same. So if you have 2, 2, 2, 2 here, that's a scalar matrix. If you have 3, 3, 3, 3 here, that's scalar matrix. So that means indirectly this identity matrix is scalar matrix. But why you will not call it scalar matrix is only one that is there. So from 2 upwards, if you have the same value on this diagonal, it's scalar. But when it's 1, it's identity or unit matrix. Then you have upper and lower triangular matrix. When you call it upper matrix, then all the values on the diagonal, this is the diagonal, from the diagonal side up, you have values there, you call them upper matrix. Then from the diagonal down, you have values there that are non-zero digits, you call it lower matrix. So this is lower triangle matrix, upper triangle matrix, because from the diagonal, it forms a triangle down, that's lower. From the diagonal, it forms a triangle up, that's upper. So that's why you call this lower matrix, lower triangular matrix, upper triangular matrix. So what you need to do, you learn the types of matrix by heart. Let them be in your mind. You know it in your head. That's what it means. Then we quickly look at matrix in business. A matrix organization is a company structure where teams report to multiple leaders. The matrix design keeps open communication between teams and can help companies create more innovative products and services. Using this structure prevents teams from needing to realign every time a new project begins. So in a matrix organization, team members, whether remote or in-house, report to a project manager as well as their department head. So this management structure can help your company create new products and services without realigning teams. Now, how can you empower teams to move quickly on complex projects without getting bogged down by stakeholder reviews and approvals? Organizational structure may be the answer. So that means if you have organizational structure, then your teams will move quickly on different kind of projects without getting bogged that stakeholders is going to give them issue. So when your organizational structure is solid, then you've got no problem. Most work environments have chains of command in place so that everyone has clarity around decision-making authority. A hierarchical organizational chart has the chief executive officer at the top, the chief operating officer and the chief financial officer are right below them. Departmental managers then branch off from the top leadership roles, with project managers branching off from there. Now, a matrix organization differs from this classic structure since team members report to both a project manager and a department head. Now, in the guide below, we'll discuss what a matrix organization is and how you can use one for complex projects. So remember that team members report to a project manager as well as their departmental head. Now, matrix in business. Matrix organizational structure in a nutshell generally describes a business with multiple managerial accountability and responsibility. So the main types of matrix structures comprise the strong matrix. The strong matrix will be the authority lies with a project manager who has a senior role within the company. That is the strong matrix. Balanced matrix. That is when it equally distributes power to both the project and functional manager. Then you now have weak matrix. The weak matrix is where power lies with functional manager completely. Now, you look at it from the strong matrix. We say the authority lies within that with a manager who has senior role within the company. Now look at the general manager, straight to the senior manager, senior manager, senior manager. Then under this, you have sales manager, one sales manager, two. For the next, all these are below the general manager because the general manager is the project manager that is spearheading everything. So that one has a senior manager that is managing the marketing manager one. That same senior manager is managing the marketing manager two. Then you still have another senior manager that is managing the engineering manager one, and that same senior manager is also managing the engineering manager two. So for the sales aspect, they all have senior manager. Then for the marketing aspect, they have senior manager. Then for the engineering manager, the engineering aspect also has the senior manager. So for sales, marketing, and engineering, they all have the senior manager that are being managed by the general manager. So general manager heads them all. Then the senior manager heads each department. So the senior manager heads the sales, the marketing, the engineering. So we move straight to the balanced matrix. So under the balanced matrix, they also have the project manager, the person that is managing everything in that aspect. So the person will also have reporters from sales, marketing, and engineering. So they have functional manager, senior manager. The functional manager, that's also senior manager. So the functional manager is referred to as the senior manager in the sales department that is managing sales manager one and two. Then in marketing, the same thing. In engineering, the same thing. They also have it under weak matrix. In the weak matrix, the power lies only there with the functional managers completely. So the functional manager are the ones that are controlling power in that sense. But in balanced matrix, both the project manager and the functional manager are managing it. So this project manager, people that are managing the project and this one, they are managing everything together. But in the strong, only the senior manager or the project manager that is managing it. Good. So after talking about the strong, balanced, and the weak matrix, then we look at uses of matrix in a real life. Matrices are used in many real-world applications, including engineering, computer graphics, security, business, economics, geology, healthcare, electronic communications, statistics, robotics. So this matrix approaches, or let me say the matrix usage, are used to solve different problems. And all the problems could come from any department, whether engineering, whether computer, security, business, economics, healthcare, and so on. So any of these aspects that this comes from, matrix can be used to solve all these problems. So they are used to solve AC network equations and even electrical circuits. All right. So let's look at matrix operation. So addition and subtraction. Matrices of the same order are added or subtracted. So by adding or subtracting the corresponding elements in each matrix. In addition, they have example. The first one is 2 minus 3, 4 and 1 plus 4, 7, then minus 2 and 6. So for you to do this, you say 2 here plus 4, and that gives you 6. Minus 3 plus 7, that's going to give you 4. Because this is
Sorry,
minus
we
3.
can't see the
This
slide
is...
you are working. Hello?
Hello? You
Yes, we
said
can't
what?
see the slide. Okay. Sorry, we just saw the slide.
Okay, I'm on matrix operations. Can you see it now?
Okay.
All right.
Yes, please.
Okay, so I said under the addition, for you to add a matrix, you pick the first number in the first row and first column. You add it to the first number in the first row and first column of the second matrix, and that gives you the first number in the first row and first column of the solution. So this is 2 plus 4, and that gives 6. Then minus 3 plus 7, that gives 4. Why? Plus 7 is positive. So 7 minus 3, and that gives 4. You can plug it in your calculator. Minus 3 plus 7, it's going to give you 4. Then 4 plus minus 2. Plus times minus is minus. So that's 4 minus 2, and that is 2. Then 1 plus 6, that gives 7. That's addition. For subtraction, 8 minus 8, that is 0. 4 minus 1, that is 3. 5 minus 2, that is 7. So minus times minus is plus. So 5 plus 2, that gives 7. Then minus 3 minus 4. Minus times minus, that's plus. So that's plus 4. Minus 3 plus 4, that is 4 minus 3, and that gives 1. So that is for addition and subtraction. You try this. Then we move to the next one, multiplication by a number. Each element of a matrix is multiplied by the multiplying number. Example. So this multiplying number is referred to as scalar multiplication because you use a number to multiply matrix. So 3 times 2 is 6. 3 times minus 3 is minus 9. 3 times 4 is 12. Then 3 times 1 is 3. Then multiplication by another matrix. For 2 by 2 matrices, example, you want to multiply this. So when you are multiplying by another matrix, you ensure that the number of rows is the same with number of columns. So the number of rows here, that is, you have row 1, row 2, must be the same with column 1, column 2. So you can have row 1 with 3, 2, 7, 4, 1, 7. So that's row 1, row 2. Then in column, it will be 1, 2, 3, 4, 5, 6. So what I'm saying in essence is where this line is pointing, this arrow is pointing, that's the same way this one will point down. So if you want to multiply this, it will be 3 times 2. That will give you this 6 plus, because there are 2 digits, 2 times 1. That is 2 here. So that's why I use red to get this, purple to get this. So 3 times 2 is 6. 2 times 1 is 2. So you add them up, you get 8. Then move to the next one. 3 times 1, that is 3 here. Then 2 times 5, that is 10 here. So 3 plus 10, that is 13. So you have used this first row to multiply these two columns. Then you go for the second row now. 4 times 2, that is 8. Then plus 1 times 1, that is 1. So 8 plus 1, that gives 9. Then you go for the next column now with this second row. 4 times 1, that is 4 here. Then 1 times 5, that is 5 here. So 4 plus 5, that gives 9. So a 2 by 2 matrix will always give 2 by 2. So the answer is 8, 13, 9, 9. So you can try this. And thank you very much. That is the end of today's class.
All right. Thank you. Wow. Thank you so much, Ebenezer. Please, a round of applause to our lecturer who has done justice to today's class. Thank you so much. Please, can we appreciate our lecturer?
Yes, I do.
And I don't know if we have any question that we could take one or two to answer that, and then we call it a day.
Okay, no problem.
Any question, please? Any question? Okay, I think everyone is just quiet. Okay, so in the absence of none, I just want to appreciate you once again for a very expository class.
Thank
It
you
was
very much.
informative. Yes, and you kind of reminded me of my matrices and indices. Thank you so much for that. And I believe everyone I believe you've gotten value for your time. Thanks again.
Thank you.
All right, so everybody, today, that's the end of today's class. If we have any information to pass across, we'll send it to your various platforms, okay? So this is also to let you know that if you are still having some outstanding to sort out with us, please do well to do so. And if you have any questions to ask, I'm always available to give answers where necessary. All right. Thank you so much, everyone. And finally, please follow us on all of our social media handles on Facebook, Instagram, Twitter. Engage on our posts, subscribe to our YouTube channel. We really need your engagement, okay? Thank you so much, everyone. And then for this very course, we'll be having our assessments in the coming week. So please keep your eye on your various platforms for that information, okay? Thank you so much for having us today, and we appreciate you for your time. Thank you, Ebenezer. Thank you. Yeah. Thank you, everyone. And do have a very beautiful weekend and a very beautiful season. All right. Bye for now.
Bye.
Bye all. Bye, bye, bye.
Bye.